वेलकम फ्रेंड्स, वेरी गुड आफ्टरनून टू ऑल ऑफ यू। सो आज हम डिस्कस करने वाले हैं थ्योरी ऑफ मशीन पार्ट 2। ओके, डे बिफोर yesterday actually we have discussed the topic, right? So we have discussed the part 1 in which we have discussed the simple mechanism in detail. Okay, whatever the topics that are important for the gate point of view, we have discussed all the topics, right? Then we have discussed the gate train, specifically the gate train part, right? Epicyclic gate train part, the relative velocity method approach, right? Okay, so tell me one thing first of all, simple mechanism and gate train part, it is clear to everybody? First of all, tell me the simple mechanism part and the gate train part, it is clear to everybody, right? So those two topics contains a lot of weightage in theory of machines. That's why we have focused on those topics in detail, right? And you have to prepare the theory of machine in such a way that the highest weightage topics should be prepared first. Okay. Okay, so in today's session we'll discuss first of all the flywheel, then governors, then gyroscope, then cam, then lastly the vibration, that is most important part of the theory of machine itself. Okay, we'll discuss in such a way. So I hope last class whatever we have discussed, it is clear to everybody, right? Okay, so in part 2 we'll discuss these topics. In part 2 we'll discuss these topics, right? So first of all, the first topic is flywheel, then gyroscope, then balancing. Oh yes, balancing is also there. See, these flywheel, gyroscope, balancing and cam, these are very small topics, right? Very small topics. But yes, vibration is contains a lot of theoretical part and as well as the numerical part. So vibration is most important. Here the formula based questions are there. Directly formula based questions will be there from flywheel, balancing, gyroscope and cam. You will see directly a formula based questions. So if you prepare the topics in such a way that if you prepare the selected formulas, selected relations, so that overall the objective of the topic is clear to you, overall objective of a topic is clear to you, then it is very easy for you to understand the questions and you can easily solve the questions as well, right? So be focused in today's session because we are targeting the flywheel, gyroscope and through formulas. We'll discuss the formulas only, right? You can solve the questions of previous year, that is more than enough for the flywheel topic, for the governor. See, in the last year, in the last topic, basically in the 2021, basically they have asked one question from the governor. Okay, so only one question has been asked from the governor, so there is some chances this year also they will ask, right? So till now they have asked only one question from the governor in gate specifically. So there are chances that they have taken the topic seriously, so definitely this year also they will ask some question from the governor also, right? So be prepared for that, be prepared for that. Okay, okay guys, we'll start the session. So please first of all, please share the session to your friends so that maximum students get benefited, right? So please share the session to your friends, and also if you like the session, so please like the session also, and please subscribe to the channel, right? Okay, we'll start the session guys. The very first topic is flywheel. The very first topic is flywheel. So can you tell me first of all the objective of flywheel? Can anyone tell me what is the objective of flywheel? Yes, please guys tell me what is the objective of flywheel. Objective of flywheel, guys, tell me first. What is the objective of flywheel? Why we use flywheel? What is the agenda behind the flywheel? So as you all know, there is two things. Flywheel is also there, governor is also there. But the flywheel is used as an energy reservoir, right? Why? So when the power is developed, see in the 4-stroke engine, we have only one power stroke. Out of 4 strokes, we have only one power stroke. That is, we are getting the energy in the 1 stroke only out of 4. Remaining 3, we don't get any energy supplied by the engine. So there is fluctuation of energy is there. So there is a fluctuation of energy is there, and as a consequence of this, so fluctuation of speed will also be there. So to balance that fluctuations, we'll use the flywheel. Okay, we'll use the flywheels. But what is the purpose of governor then? See, purpose of a governor is just to balance the variation in speed also, right? But because of the variation in the load, there will be variation in the speed. So to balance that, we'll use the governor. So governor is totally different with respect to the flywheel. Both are different things. You should know the difference between flywheel and the governor, right? Obviously they are balancing the fluctuations in speed, right? Obviously, but the fluctuation in speed, the reason of fluctuation of speeds are different in flywheel and governor. So when we talk about the flywheel, the reason is what? The fluctuation in the energy supplied by the engine. Okay, fluctuation in the energy supplied by the engine. But in governor case, there will be the fluctuation of load, because of which speed will change. Okay, and obviously we don't want our speed to suddenly fluctuate, right? Because it will be uncomfortable for us. Okay, it will be very uncomfortable for us if the speed fluctuates frequently. Okay, if the speed changes frequently, then it will be very uncomfortable for us. So to balance out these things, we'll use the governor, and because of governor, fuel supply will be regulated. Fuel supply will be regulated. But in the flywheel, we are not regulating the fuel supply. What we are doing, we are balancing the fluctuation in energy that are produced within the engine only. So in 4-stroke engine, 4 strokes are there, only 1 stroke will giving the power. So whatever the extra amount of energy we are getting, that energy is stored in the flywheel. So that's why we are calling it as an energy reservoir, right? Governor is not an energy reservoir, right? Flywheel is called as an energy reservoir because it absorbs certain amount of energy. Which energy? The surplus energy. Okay, during the power stroke, it is producing the power more than that required. What is required by the engine, it is more than what the engine has supplied. So let's suppose engine required 100 kilojoule of work, right? 100 kilojoule of energy it is required, but at the time of power stroke it is producing 150. So remaining 50 kilojoule will be absorbed by the flywheel. So whatever the surplus energy we are getting during the power stroke, that is stored by the flywheel. So this is the concept, or this is the basic objective of the flywheel. Okay, please remember this particular thing. Now, what are the different important things that we need to know while we discuss the flywheel topic, right? See, first of all, understand this thing. So whatever the work done will be there, per cycle, it will be equals to what? Area under T theta diagram, right? Work done per cycle equals to what? Area under T theta diagram, right? So what is the area? See, what there will be some torque, expression of a torque will be given to you. Okay, so you have to just integrate this thing, T d theta, and what will be the range? 0 to time period, whatever the time period is there. So you have to integrate it. So this will be the work done per cycle. Okay, please remember this particular formula, very very important, right? Now see, time, what is time period? See, actually after this is the theta, it is also the value of theta only, but after this particular theta, the cycle again repeats. That's why we are calling it as time period, right? So you have to integrate the T d theta from 0 to time period. Time period is the value of a theta for which the cycle repeats itself, right? So remember this particular thing, the time period, right? So obviously the work done is nothing but the T d theta. So T is what? T is a function of theta, and what is theta? Theta is the what? Crank rotation. Okay, it is what? Crank rotation. T is what? Torque, right? Okay, it is clear to everybody. So torque is a function of theta, where theta is the crank rotation and T is the torque. Okay, so it is very important for us to understand that it is what? Torque is a function of theta, theta is nothing but the crank rotation. So whatever will be the crank rotation, accordingly the torque will vary, right? So it is clear. Now let us suppose if we consider the 4-stroke cycle, and if we talk about the 4-stroke, how will be the area, or how we can calculate the area of T d theta diagram, right? So but first of all, we should know how the torque varies in 4-stroke cycle. how stroke will vary in 4-stroke cycle with respect to crank rotation. That is the important point we should know, right? So we'll draw the diagram here first of all. See, we'll draw the diagram first of all. Now carefully observe this particular thing, right? So can you tell me the 4 strokes of a 4 strokes in a engine? What are the 4 strokes? Can you name them? What are the 4 strokes? Anyone? Tell me fast. What are the 4 strokes? Can you tell me? Anyone? What are the 4 strokes? In IC engine, definitely you have studied about this. Different 4 strokes are there, na? Suction, compression, power and exhaust, right? Yes or no? Tell me fast. This is clear to everybody? Yes, tell me fast. This is clear to everybody? Yes or no? This is clear. So suction is there. So during the suction, what? Engine is doing the work, right? Engine, we are doing the work on the engine. Work is done on the engine, right? So it will be like this, right? Then compression will be there. Then power stroke will be there. See, so lot of work will be there on the compression part. Then power stroke. Then exhaust. Finally, it will exhaust. So please understand this particular things. Here up to this, it will be pi. Here it will be 2 pi. Here it will be 3 pi. And here it will be 4 pi. Now, carefully observe this point. This is what suction. This is what compression, power, exhaust, right? Suction, compression, power, exhaust. Okay, so these are the different strokes in a IC engine if we talk about the 4-stroke cycle. Now, please carefully observe that. Carefully observe. This is what the torque axis, this is what the theta axis. Theta is nothing but the crank rotation, right? Now, obviously, see, this point is very clear that the variation of a torque, we are having what? A fluctuation in a torque, and definitely if there is a fluctuation in the torque, so definitely we are getting the fluctuation in the speed as well, okay, as well, right? So if we are talking about the torque fluctuations, there will be some fluctuation in the speed as well, right? So we have to balance out. So actually when we running an engine, a constant resisting torque is required, some mean torque is required, right? So if we provide that particular mean torque at every instant, then there will not be any fluctuations. But actually in practical life, it is not possible to provide that particular mean torque, okay? Because you have studied the 4-stroke cycle. Power is producing in 1 cycle only, in 1 stroke only. So how we can provide a constant amount of torque throughout the cycle? It is not possible. It is not practically possible, okay? But remember one thing, whatever the energy we are getting during the power stroke, it is more than required. So whatever the surplus is there, it will be absorbed by the flywheel, and whatever the amount that has flywheel has stored, that will be utilized when there is no supply of energy from the engine. Are you getting my point? Are you getting my point? First of all, tell me, all of you, it is clear everyone? So these points are very important to understand while analyzing the flywheel. Okay, let's suppose I am assuming a constant torque, a mean torque basically. Let's suppose this is the mean torque I am taking. Yes. Now, please carefully observe. Let's suppose this is the mean torque at which engine will work perfectly fine. Engine will work at mean torque. If we are supplying the mean torque, then there will not be any fluctuations. Okay. So let's suppose this is the mean torque. It is considered as a mean torque. Why? Because at this mean torque, the total amount of work done will remain same. Okay. If we consider this mean torque, the amount of total work done will remain same. How is it possible? See, what we have said, work done per cycle, it is equals to T d theta, okay, 0 to time period. This is the formula we are having, right? It can be equals to T mean multiplied by theta. And what will be the theta? Time period, right? Multiplied by time period. Whatever the time period we are having, let's suppose we can say accordingly, okay? Whatever the time period we are having, we'll say. Ranjini, yes, you will be getting the PDF, okay? But it is better to see the total session because it will be very helpful for you, right? Because how we are discussing the various relations, how we are discussing the different relations, how we are connecting the different relations, that is very important, okay? That is very important. So it is not just ki you have to mug up all the relations, you have to understand how the relations are there, what are the conditions, and under which conditions they are valid. So we should also know the conditions, we should know the assumptions behind all the relations, okay? Ranjini, you will get a Telegram link in the chat itself. You will get a Telegram link. See, in the chat box, you will see a Telegram link and you have to go to the Telegram link and you will get the PDFs. Okay, don't worry about the PDFs, but just attend the session carefully. Okay, you have to be very attentive throughout the session. It is just a 4-hour session, or less than 4 hours will be required actually. So in this 4 hours, we will be completing all the topics through formulas. So at this time, the formulas are very important. As you all know, as this moment, formulas and relations are only important. We are not solving any questions, but we are discussing the formulas that will be utilized or that will be used in solving numericals. So we will be focusing on the numericals, not on the numericals, but the formulas and the relations part, right? So we have to be very focused on the formulas and relations. Now, please carefully observe that. Now we got the formula here. Work done per cycle equals to T mean torque multiplied by the time period, right? This is the formula that we are getting, okay? This is the mean torque multiplied by the time period, and it is also equals to integration T theta, or it is also equal to area under T theta diagram, right? We can also define like this. So remember this particular thing, this point, right, that we have written like this, okay? Work done equals to area under T theta diagram, 0 to time period, right? These are the limits, 0 to time period, these are the limits, right? Then we have defined mean torque. We have defined the mean torque in such a way that the amount of work will remain same, okay? It is clear. Up to this point everything is clear. Tell me first. Up to this point everything is clear. Tell me. Up to this point everything is clear. Okay, great. So when we have defined this mean torque, you should know that there will be some situations when the actual torque will be greater than the mean torque. Actual torque will be greater than the mean torque, and there will be some cases in which actual torque will be less than mean torque, okay? So it is very common, or we can use just a common sense here. When the actual torque is greater than this mean torque, it will be what? Acceleration will be there, okay? Surplus amount of energy we are getting, okay? And below the mean torque, a retardation will be there. Below the mean torque, what will be happening? The retardation will be there. So please carefully observe that. If T greater than T mean, then we can say T minus T mean torque equals to I alpha, where alpha is what? Angular acceleration and I is mass moment of inertia. And if actual torque is less than mean torque, then we can say mean torque minus actual torque equals to mass moment of inertia into alpha. But carefully observe that here alpha is angular acceleration and here alpha is angular retardation, or we just will write just a retardation. Tell me fast. This is clear, guys. This is clear. This is clear. Okay, great. So these are the two cases that we should know. Okay. Now we will have to see what are the different important parameters that we need to know while discussing the flywheel part. Important parameters. Some important parameters are there. Right. Some important parameters. Okay. Now tell me, what are those important parameters? Remember the coefficient of fluctuation of speed, coefficient of fluctuation of energy, fluctuation of energy, right? All those terms are very important. All those terms are very important, right? Tell me fast, what is coefficient of fluctuation of speed? Can anyone tell me? Coefficient of fluctuation of speed. What is the coefficient of fluctuation of speed? Anyone? Coefficient of fluctuation of speed. See, we'll represent it with the help of CS. Right. So please carefully observe. CS equals to N max, maximum speed, minus N minimum speed divided by N mean. Clear? This is the formula that we need to apply wherever the coefficient of fluctuation of speed is given. Okay. Now what is N mean here? Please see. N mean is nothing but maximum plus minimum divided by 2. This is the mean. In place of RPM, N is basically what, revolutions per minute. In place of RPM, you can also use omega, that is radian per second, right? You can use that also. Okay, so coefficient of fluctuation speed, it is important, right? It is important. In place of N also you can use omega. See how you can write. Omega max minus omega minimum divided by 2, like this. Okay. So next important term is coefficient of fluctuation of energy. Coefficient of fluctuation of energy, right? Now see. It is represented by CE. Again, same formula as we have discussed in CS, coefficient of fluctuation of speed. Here the coefficient of fluctuation of energy is there. E max minus E minimum divided by E mean. And E mean is nothing but the work done per cycle. Okay, E mean. So this is the formula of coefficient of fluctuation of energy. Now, the third important parameter, see, the third important, so first important parameter is CS, the coefficient of fluctuation of speed. Now, third important parameter is fluctuation of energy. What is that fluctuation of energy you are talking about, right? Fluctuation of energy. What is the formula for the fluctuation of energy? Please carefully observe. See, delta E equals to E max minus E minimum. Right? This is the formula you need to understand. And how we can modify this particular formula? See, half I omega max square minus half I omega mean square. So this is the one form of fluctuation of energy. This is another form. In another form, we can also write it like this. Delta E equals to I omega square Cs. This is important. Most of the times you will be using this particular formula. You will be using this particular formula, right? Very, very important. Okay. I omega square Cs. Okay. Where omega is what? The average, or we can say mean angular speed. What is Cs? Coefficient of fluctuation of speed. And what is I? It is mass moment of inertia. Mass moment of inertia. Okay, it is clear, guys. It is clear to everybody. It is the mass moment of inertia. What is the formula for the mass moment of inertia? Please see. Mass multiplied by the radius of gyration, mk square. Okay, but let's suppose they have not given the radius of gyration. See, they just mentioned it is a disc or it is a cylinder. See, they have mentioned like it is a rim or it is a cylinder or it is a disc type flywheel is there or rim type flywheel is there. So you have to apply the formula accordingly, right? So if they didn't mention the shape, okay, if they didn't mention the shape, they will give the mass and they will give the radius of gyration. Okay, so by this formula you can get the mass moment of inertia. But if they are saying it is a rim sized flywheel, then what is the mass moment of inertia? Then what is the mass moment of inertia formula? Guys, tell me fast. Tell me what will be the formula if there is a rim type flywheel. For a rim type flywheel, what will be the formula for the mass moment of inertia? Tell me fast, guys. Tell me fast. What will be the formula for the rim type flywheel? Thanks, Vijay. Tell me, guys, what will be the formula for the rim type flywheel? See, two cases are there, na? If there is a disc type and there is a rim type. So you need to understand what are the formulas. See, for the rim type, the formula is mr square, and in case of disc type, formula is mr square by 2. Right? These are the formulas that you need to apply. These are the formulas that you need to apply. Okay? Clear? So this important formula, the maximum fluctuation of energy, you can calculate by I omega square Cs. Okay? You can also again modify this particular formula. How? See, you just need to remember one formula, right? You just need to remember this particular formula. From this formula itself, you can get this one, you can get this one, you can get this, all this, the formulas. Right? The another format that we are talking about, another format is what? If you write it like this, see, if you write it like this, delta E equals to, just multiply and divide by the 2, multiply and divide by 2. Okay, you are doing like this, just multiply and divide by 2. Now, please carefully observe, within the bracket term is nothing but the mean energy. Within the bracket term, there is nothing but the mean energy. Okay, so we can say here, the formula again reduces to 2E Cs. So this is the formula that we need to again remember. So this is also important. This is also important. Okay, both these formulas are important. Okay, clear everyone, each and everyone, it is clear, right? So now if they are asking the power, so remember the formula for the power will be, you remember the formula for power, power equals to torque into omega, everyone knows. But please remember this thing, the whatever the torque you are considering, it will be the mean torque. Okay, it will be the mean torque. Okay, because we are calculating the power at the mean torque only. Okay, whatever the power the engine is delivering, it is based on the mean torque, not on the max or mean. You just need to take the mean torque, and obviously the mean speed as well, right? Tell me fast. uh, just 1 minute guys, just 1 minute. I think there is some technical issues there. Just 1 minute. Welcome back everyone. I hope audio is clear to everybody. Tell me fast. Audio video both clear? Tell me. आपका आवाज clear आ रहा है? And also the video is also clear. Tell me first. Is it okay now? Guys, actually because of the technical issue the session was stopped for some time. Okay, now we are again starting the session. So up to this point we have discussed some basic details of flywheel. What is the purpose of using the flywheel? What are the important parameters that we have to discuss in flywheel that we are discussing, right? Okay, everyone, tell me, it is clear to everybody? Now it is clear? Yes, tell me fast, guys. It is clear to everybody? Okay, great, guys. So, moving to the next part. See, we have discussed this much things. Up to this points we have discussed. Okay, we have discussed this thing. We have discussed the cycle. What is the work done per cycle? The mean torque we have discussed, right? The mean torque, if you multiply the mean torque. Bhavesh Mishra, audio is not clear. Bhavesh, what is not clear? Tell me. Bhavesh, audio clear? Yes, tell me first. Audio is clear, na? Audio is clear? Bhavesh Mishra, right? So, yes. Okay. So, we have discussed these things, right? Then after, see, work done equals to mean torque multiplies the time period, right? Okay. Bhavesh Mishra, engineering. Please specify your question, guys. Bhavesh, what actually you want to ask? Please mention your question in detail. Actually, I'm not clear with your question. But actually, you want to know? Tell me. But I don't know what you want. Anything specifically you want to ask from this coefficient of fluctuation of energy or fluctuation of energy? It is clear to you? The fluctuation of energies, right? And this, the formulas for the fluctuation of energy of a flywheel, right? Okay. So these terms, these parameters are important for the flywheel. Now please understand, most importantly, see, sometimes they will give you the expression of a torque. They will give the expression of a torque like this. Let's suppose 10,000 they have mentioned plus 5,000 sine 3 theta, right? So this is the expression for a torque they have given like this. Now to integrate this one or to calculate the mean torque, you have to what? You have to apply the formula. Which formula you have to apply? See, which formula you have to apply? See, work done per cycle equals to the mean torque multiplied the time period. This is the formula we are having now. Now if you want to calculate the mean torque, see, work done per cycle divided by time period. This is the formula we are having. This is the formula, right? But how to calculate the work done per cycle? Just integrate the whatever the expression that is given, right, from 0 to time period. Now most important question here is that first of all you have to calculate the time period, right? So for calculating the time period, see, what is the time period? Time period is actually the value of theta after which the cycle again repeats itself, right? Tell me, this is clear? This is clear, yes or no? This is clear? So how to calculate the time period for this particular thing? See, they have given the sine 3 theta, but actually first of all you should know what is the time period for sine theta. First of all, for sine theta time period is 2 pi. Now if they are giving the sine 3 theta, you just need to do what? 2 pi divided by 3. 2 pi divided by 3. Similarly for cos theta also, the time period is 2 pi. Let's suppose they have given cos of 5 theta. So you just need to do what? 2 pi by 5. So please remember this particular formulas for the time period. It will be very helpful for you. It will be very helpful for you to calculate the time period, right? So if the sine 3 theta is there, so for this particular thing, time period will be time period will be 2 pi by 3. 2 pi by 3 will be the time period for this particular expression. Okay, I hope this is clear, right? So whenever this type of expression is given to you, just calculate the time period, and if the time period is known to you, then you can directly calculate this mean torque. And it is very important, guys. It is very important to calculate the mean torque. Okay, because mean torque is required to calculate the power. As you all know, whenever they are asking for the power, you just need to do what? You have to multiply the mean torque with the mean speed. Okay, always remember this particular thing. We have to calculate the power at the mean torque only. Okay, so if someone is asking calculate the power delivered by the engine, so just need to multiply the mean torque with the mean speed. Tell me, each and everyone, up to this point everything is clear? Up to this point everything is clear? Tell me fast, guys. Up to this point everything is clear? Yes or no? Yes or no? Clear na? Okay, guys. Okay. One more important relation with regards to dimension of flywheel. Dimension of flywheel. Please see. For calculation of maximum velocity, under root sigma divided by density. Please remember these things. Sigma is nothing but the hoop stress. What is the permissible hoop stress they are giving? You have to use that. Whatever the permissible limit of hoop stress they are giving, you have to use. Density. Rho is nothing but the density. Okay. So this particular formula will be helpful for you to calculate the dimensions of a flywheel. Right. Sigma is what? The hoop stress. They will give the permissible limit for that. Obviously hoop stress will be there, but a permissible limit for that particular stress will be given. Okay, and according to which we can calculate the maximum velocity. And rho is what? The density of a material of a flywheel. Rho is the density of a material of flywheel. Okay, clear everyone? Clear? So please note it down, these particular formulas. These formulas are directly you have to use this formula directly in your examination, gate examination. Okay, so directly formula based questions they will be asking. If you see the previous year gate questions, a direct formula based question has been asked from this particular topic. Okay, so note it down fast, guys. Note it down fast. Okay, done. Moving to the next part is the governors. Okay, next part is what? Governor. Okay, we have discussed the flywheel and we have also discussed the difference between the flywheel and governor. Okay, I hope this is clear to everybody. Now, in governor's topic, you have to be very specific, because in this governor topic, lot of governors are there. So we have to specifically select those governors that are very important for the gate examination, right? So we'll be discussing the centrifugal governors. Okay, there is a classification of inertia and centrifugal, but inertia governors are not in much use. That's why we don't study that much for that inertia governors topic. Okay, we'll not study that inertia governor topic. Okay, most of the famous governors will be based on centrifugal. So we'll be discussing the centrifugal governors, right? Centrifugal governors, right? Centrifugal governors you have to study. Inertia governor is also there, but it is not important, right? In centrifugal governors, two type of varieties are there. First one is the pendulum, and another one is what? The weight. Okay, weight type, dead weight type Okay, and we can say the spring controlled governors are there. Okay, now can you tell me the name of spring controlled governor? Can you tell me the name of spring controlled governor, guys? Tell me fast. Can anyone tell me the spring controlled governor? What is the spring controlled governor? Anyone? See, at least you know the basic classification. First one is what? Pendulum. Another one is what? Loaded. In loaded, two types of loading will be there. Dead weight and another category what? Another category was the spring control. Clear, everyone? Now, dead weight and these things are there. So, pendulum, we are having the watt governor. Okay, and dead weight, we are having two different varieties of dead weight governors. First is Porter and Proell. Another one was the Proell. Spring control, if I talk about spring control, first is Hartnell governor. Okay, another one was the Wilson Hartnell, right? So at least you should know the names. Another one, Pickering governor. And one more example for the spring control is the Hartnell governor. Right, all of these names should be clear to you, because in some examination they will directly ask which of the following will be the spring control governor. So in that particular scenario you should know what are the spring control governors. Okay, loaded, two types of loaded governors are there. First one is dead weight, another one was spring controlled, right? So note it down fast, guys, note it down fast. Okay, done everyone. Okay, moving to the next part. See, a basic concept you should know, how the governors are acting. What is the basic principle of operation of the governors, right? So see, governors are doing what? The balancing the fluctuation of a load. How they are doing that? See, carefully observe. See, two cases are there. Let's suppose first case, let's suppose if we are talking about the first case, in first case, let's suppose load is increasing. So obviously if load is increasing, what will be happening? What will be the effect of increasing of load on the speed? What will be the effect on the speed, guys? If load is increasing, speed will be decreasing, right? Speed will be decreasing. Obviously, if you are putting the load on the vehicle, so definitely its speed will going to decrease. Its speed will going to decrease, right? Okay. So speed will going to decrease. So obviously we don't want the decrement in the speed. We don't want that. So what will we do? What we can do in case of this governors? So actually what we are not doing anything, but the governor is doing. What the governors are doing, you have to focus, right? So if the load increases, speed decreases, this is the problem. Speed decreases, this is our problem, and we have to tackle it. How we are tackling? So if the speed decreases, there will be the sleeve movement in the governor. Okay, and because of the sleeve movement, there will be the changes in the throttle opening. There will be changes in the throttle opening. Because of the speed decrement, sleeve movement will be there. And because of sleeve movement, throttle opening will be there. Now, obviously, throttle opening will be there. If you want to supply the fuel, throttle will be open. But how much amount of fuel is coming into the engine, it totally depends upon the throttle opening, how much the throttle has been opened. Okay. So as the load increases, you just need to do what? you just need to do the increment. You have to increase the opening of a throttle so that more amount of fuel can enter. So that more amount of fuel can enter into the engine, and if more amount of fuel is entering into the engine, more amount of power will be developed, and more amount of power that is developing will balance the increase in load. Right? It is clear to everybody, guys. Whatever the amount of fuel it is entering, let's suppose now because the load has increased because of the movement in the governor, right? Because of the movement in the governor, fuel supply was increased, and because of the fuel supply is increased, power developed will also increase, and increment in the power development, whatever the power has developed, there will be some increment in that, and that will balance the increment in the load. So in this particular way, we'll be balancing the increase in the load. Guys, tell me first, this point is clear? This point is clear to everybody? Yes or no? Yes or no? It is clear? Okay. So if you see the basic format of governor, you will see as the load increase, speed decrease, and because of speed decrement, sleeve movement will be there, and it will what? Sleeve moving downward, we'll write it like this. Sleeve moves downward. We'll write it like this, sleeve moves downward. And if sleeve moves downwards, throttle opening increases, and because of which fuel supply increases. Right, this is the first scenario. Second scenario, load decreases. Let's suppose load decreases, and if the load decreases suddenly, speed will increase definitely, and actually we don't want sudden change in the speeds, right? We don't want sudden change in the speeds. We want that vehicle should run at a constant speed, because at the constant speed we will be feeling the comfortability. We will feel comfortable when our vehicle is moving at a constant velocity. Okay, we don't want the sudden changes in the velocities, because if there is sudden changes, we will be feeling the jerk, right? So load decreases, speed increases. Obviously in that particular scenario, sleeve moves upward, and obviously throttle opening will be, in this case, throttle opening basically in this case decreases, and as a result of which fuel supply decreases. Fuel supply decreases. Clear? And here in this case fuel supply increases. Right? This is the principle of operation if we talk about the governors. Now see, we'll draw just a basic diagram here. We'll draw just a basic diagram of a governor so that it will be clear to you how our governor is working. The basic overall working of a governor will be clear to you. See, carefully observe this thing. See, this is your sleeve part. This is your sleeve part, right? Now carefully observe. Okay, this is your sleeve, right? Now we'll be putting some stopper here. We'll be putting some stopper. Similarly, here also a stopper will be there, right? Okay. Now, how this governor is working? See, because of what? This gear. This gear is there, right? okay, and shaft is connected to this one, okay. So this is what engine shaft. This is what the engine shaft, okay. This is what engine shaft. Clear? Everyone, each and everyone, it is clear. So this is your engine shaft. From the engine shaft, motion has been transferred to the governor. Motion has been transferred to the governor. Now let's suppose load decreases, speed increases. It is very obvious thing, right? Speed will increase. So when the speed will increase, na, obviously because of this gear, it is what the bevel gear, na, right? So because of this gear, the shaft will rotate, and as the shaft rotate, this balls will be rotating at a high speed. When it is rotating at a high speed, it will move upwards, and if it move upwards, it will take the sleeve in the upward direction. Basically, sleeve will move in the upward direction. Now, there is a spatial arrangement is there. A spatial arrangement is there that is connected with this sleeve part. Right. With the sleeve, a spatial arrangement is there which is connected with the sleeve. Okay, that is known as the ball crank lever connect arrangement. A ball crank lever mechanism is there, right? Okay, ball crank mechanism is there. Right, like this. So, first of all, remember this particular gear is known as the mitre gear. A very important question. With a velocity ratio equals to 1:1, right? With velocity ratio equals to 1:1, right? So exact size of mitre gear will be there, because we want whatever the changes in the engine shaft is there, na, same amount of changes will be there in the governor. Okay, whatever the engine shaft is there, whatever the motions are there in the engine shaft, exact same motions will be there on the governor shaft. So sensing the changes in the speed, governor will act accordingly, okay, and it will regulate the fuel supply. It will regulate the fuel supply. Everyone, it is clear? Guys, everyone, it is clear to everybody? It is clear to everybody, guys? Tell me first. Okay. It is your throttle, right? This is ball crank lever mechanism. So lot of mechanisms will be there in a system. Okay, lot of mechanisms will be there in the system, right? So it is clear to everybody, right? So in this way, our governor is what? Regulating the fuel supply. Governor is what? Regulating the fuel supply. It is doing what? Regulating the fuel supply. Okay, and because of the regulating the fuel supply, because it is regulating the fuel supply, the changes in the speed, the fluctuation in the speed can be balanced out, right? So how it is regulating? Based on the changes in the load, there will be changes in the velocity. So whatever the changes in the velocity will be there, will be doing what? The regulating the fuel supply. Now come to the important part. So this is the basic operation that you should know. This, first of all, we'll discuss the Watt governor, then Porter, then Proell, then Hartnell governor. We'll discuss all these 4 governors that are very important from the gate point of view. And actually, in the 2021, they have asked a question from the governors, right? So lot of chances are there in this gear also, in this gate examination 2022. This year also they will ask. Why? Because up to this point, they've only asked only one question. They've only asked only one question up to this point, right? Only one question they have asked from the governor chapter. So obviously there is lot of scope is there, because it is what? A untouched part in the theory of machine subject. It is untouched part, so lot of scope is there. a lot of questions can be created, can be developed from this particular topic. So you have to be prepared for this particular topic. Specifically this topic I am focusing, because chances are more, and definitely you will get some question from this governor topic, right? Be careful about that. You have to select the topics like Porter and Proell. You should just know the formula. If you just know the formula, if you just know the relation, you can easily solve it. Same thing with the Hartnell governor. If you just know the basic formula and the relation, you will be able to solve the question, right? So definitely you will see some question. Definitely you will see question from Watt, Porter, Proell or Hartnell. Out of these 4 governors, you will definitely see one question. It's my guarantee. I will definitely, please remember this particular point. You will see a one question from this particular topic. For sure you will see. Now see, I hope this is clear to you. Now we'll discuss what governor. Right, what governor? See, carefully observe. See, let's suppose this is the axis of rotation of a governor. This is the balls connected to that. Right, like this. Like this, this is your Watt governor, right? Okay, carefully observe. So first of all, you need to understand some important parameters in the governors. While analyzing the governor, you should know some basic parameters, right? See. So carefully observe this point. This is H. Height of governor, right? This is R. And it is what? The radius of governor, or we can say radius of rotation. Radius of rotation. Okay, it is clear to everybody? It is clear? Tell me guys fast. It is clear? It is clear? Obviously, see, in Watt governor, important point is there. Mass of a sleeve. Sleeve, we consider the sleeve as massless, right? Is assumed to be massless, right? This is important. Okay, so that's why it is like this. Okay, you can make a point here. Right, now please carefully observe this particular thing. See, a mg force will be acting downward, a centrifugal force will be acting like this, mr omega square, like this. Whatever the omega, that is the angular velocity of this axis of governor, whatever the angular velocity is there for the governor, will be having this centrifugal force. Fc is what? mr omega square. Mg is the basically what? The downward force, right? So for the Watt governor, you have to remember this important particular formula, right? What is that? N square equals to 895 by H. Very, very important. Okay, please carefully remember this particular formula. There should not be any mistakes while remembering this particular basic simple formula, right? So 895 by H, N square equals to 895 by H. This is what the formula for the Watt governor. Okay, directly formula based questions will be there from this particular Watt governor. Okay, H they will mention in centimeter, they will mention in mm, but please remember this particular thing, you have to put those values, you have to put those values in meter only, right? So remember this particular thing, in meter, right? Please remember this thing. And n, whatever the n you are getting, it is in rpm. Okay, clear? So this is the watt governor, very simple, very simple. Now next important thing is that the Porter governor. Porter governor we will discuss. Next important term, the Porter governor. Okay, see, please carefully observe. Again, the axis of a shaft is like this, right? Now this is the ball attached like this. See, now the sleeve has a mass. Okay, let's suppose some mass is there. Okay, mass of sleeve. Now in this particular scenario we have considered the mass of sleeve, and also we have put some mass, we put some weight actually on the sleeve. Okay, by intentionally we have put some weight on the sleeve. Okay, we have intentionally put some weight on the sleeve. So let's suppose it is a total mass of a sleeve, considering the whole, whatever the body you have put it on the sleeve, the whole mass of a sleeve we are considering as capital M. Small m, please carefully observe. Now the small m, the mass of ball, right? So again same thing you need to understand, the centrifugal force mr omega square, this is the downward mg force, right? Again important term, this is what, the radius of rotation, right? This is what height, this is what r, radius of rotation, h and r, it is clear. H is what, the height of a governor, and r is what, the radius of rotation. Now here also you need to remember the direct formula for the rpm, n square equals to 895 by h. Okay, it is similar to what governor, 895 h. One more thing is there in the bracket, please remember, mg plus capital mg plus minus f by 2 1 plus k divided by mg. So this particular expression is clear to you. Okay, tell me guys, this particular expression is clear to you, yes or no? Now you should ask, sir, what is F, what is K? See, F is the friction force, K is the ratio. Which ratio? Please see, carefully observe the governor axis first of all. Then see this particular thing. This arm you have to consider the upper arm or lower arm you have to consider. This is the ball. Now another arm is like this. It is connected to like this. Okay, great. Now please carefully observe. Okay, here capital Mg plus minus frictional force divided by 2 will be there. Okay, this is your Mg, this is your centrifugal force, mr omega square. This is the case. Now obviously some angle will be there, theta, and some angle will also be there like beta. So K is nothing but the ratio of tan beta divided by tan theta. Okay, F is what, the frictional force. frictional force is there. Now, by intentionally I have put plus minus sign here. Can anyone tell me why we have put the plus minus sign? What is the reason behind that? What is the reason? See, actually, you have to consider this thing importantly. When the sleeve move upwards, friction force will moving downward. Friction force will be moving in the, so friction force will be acting at in the downward direction, right? When the sleeve is moving upwards, friction force will be acting in the downward direction. Yes or no? It is clear. Now consider this point. If the sleeve is moving downwards, friction force will be moving upwards. But you remember the mg, the weight, it will always be directed towards what? The downward direction. The direction will be always downward, always. Whatever the motion of the sleeve, irrespective of the motion of the sleeve, the weight will be acting in the downward direction. Clear? But if the friction force is considered, it will be positive when the sleeve is moving upwards, because in that sense, in that particular scenario, it is acting in the downward direction. So please remember this thing. Friction force positive when sleeve move upward. When sleeve moves upward. Clear everyone? When sleeve moves upward. And negative sleeve moves downward. When sleeve moves downward. It is clear? Yes, everyone. It is clear to everybody. So this is a very important formula. Let's suppose in most of the cases they will be giving k value is 1. And how we can know the k value is given as 1? See, they will mention the length of both the links as equal, right? So if both the length links are equal, let's suppose I'm mentioning this as AB. The length of upper link and the lower link are equal. Then in that particular case, k will be 1. Okay. So remember this particular thing. K will be 1 when A equals to B. Okay, this condition you should remember. So what is A and B? A and B are nothing but the length of upper link and the lower link respectively. It is clear. It is clear. Now, so K value can be 1, friction force can be 0. We can assume friction force as 0. So in that particular scenario, how the formula will be converted? How the formula will be modified? Please see. N square 895 by h, right? Now it will be 1, so 1 plus 1 become 2, 2 cancel out, friction force is 0. So here mg plus capital Mg is there, and in the denominator small mg is there. If you cancel out the g part, you will get what? Small m plus capital M divided by small m, right? So this is the formula. When k is 1 and friction force is assumed as 0. So under this particular condition, this formula will be applicable, right? So N for what? Porter. For Porter governor, this particular formula will be there. So tell me guys, this is clear? Yes or no? This particular topic, this particular point is clear? Yes or no? Each and everyone, this is clear? Each and everyone, this is clear? Yes, yes guys, okay, great. Okay, so after the Porter governor, we have to discuss the Proell governor. We have to discuss what? The Proell governor. We have to discuss the Proell governor. Right, Proell governor we have to discuss. See, if you talk about the Proell governor, it is similar to Porter governor, but a little bit difference is there. Because in the Porter governor, you see this is upper arm, this is lower arm, but in the Proell governor, you will see a difference in the upper arm. Okay, you will see a difference in the upper arm. So how the difference is there? What is that difference? Please see. Okay, clear guys. So you see this is extension of the upper arm. So you are noticing the extension of the upper arm. Guys, tell me. So it is different with the Porter governor. Na? There is no extension of the upper arm, but in the Proell governor, you will see what? The extension in the arm. You will see the extension in the arm, right? You will see the extension in the arm, right? So a lot of varieties of the Proell governors are there. A lot of varieties of varieties in the Proell governors you will see. Okay, this is one variety. Another variety you will see like this. See, carefully observe. Carefully observe this particular thing. Like this also you will see. Okay, so this is what a Proell governor. This is what a Proell governor. Clear? So you will find a difference in the Porter and the Proell governors while looking at the links. While looking at the links, right? Okay, while looking at the links part. Clear, each and everyone? It is clear? Okay, it is clear. Now, please carefully observe. Let's suppose this particular extension's length are considered as A, and if I consider this length from here, let's suppose E. So the only change in the formula will be what? Please, 895 by H into A by E, same bracket, whatever the expression we have written for the Porter, same we have to apply here. Same we have to apply. Mg plus minus, sorry, first of all we have to write capital Mg plus minus frictional force divided by 2, 1 plus K like this. Clear? Like this the value of N will be there. So this particular formula will be clear to you. See, you have to consider this important things, A and E. A and E. A is the extension part, the length of extension part. E is what? The distance of that particular ball from this sleeve. From this sleeve you have to measure the distance. So if these distances are known to you, then you can easily calculate the what? N. You can easily calculate the value of N if you know the values of A and E. Basically it will be given to you in the question itself. They will give these values A and E, but you should know what is A, what is E. A is the extension part, right? A is the extension part, and E is what? The distance of E from the sleeve part. E is what? The distance of the ball from the sleeve part. So it is clear, guys. Tell me fast. It is clear? Yes or no? So first of all, note it down this particular formula, and after this we will discuss the Proell governor. The last important governor type, the Proell governor, will discuss. We'll discuss the Proell governor. Please note it down fast. So after this we'll discuss Hartnell governor, the spring control governor will discuss. Right. So already we have discussed this Porter, what, the classification we have discussed, basic principle we have discussed, right? This is the classification, this is the principle, this is your governor, right? Then we have discussed the what, Porter, then we'll discuss the Proell. Now we'll discuss the Hartnell governor. Okay, we'll use the Hartnell governor. Okay, some question has been asked from the Hartnell governor in engineering services, right? In engineering services prelim examination, they have asked some question from the Hartnell governor. So a lot of chances are there. They can GATE can ask similar type of questions from the Hartnell also, because GATE has not asked till now. They have not asked the questions from the governors, right? They didn't touch this particular topic. So definitely you will see a Hartnell governor question in GATE 2022, right? Please be sure about that. Hartnell governor, from Hartnell governor you will see a question in GATE 2022. Okay, just you need to understand some basic points, basic relations and formulas. If you know that particular relation, then you will be able to solve those questions. Okay, very easily you will be able to solve. Very easily you will be able to solve all those questions, right? Clear everyone? Clear everyone? Now see, as we have said earlier also, it is the spring controlled governor. Spring controlled. It is spring controlled governor, right? Now right, so let's suppose this is the ball you are having. This is the ball you are having. Now consider the axis of rotation, right? This is what axis of rotation. Clear? This is the axis of rotation. Pranjali, yes, okay. So this is the axis of rotation, this is the Hartnell governor, right? So definitely chances are there you will see question from this Hartnell governor. So you have to be very attentive in this session, so that you will be able to understand what is Hartnell governor and how we can solve the questions from the Hartnell governor itself. So two type of questions they will be asking: the stiffness of a stiffness for this particular Hartnell governor, right? They will ask the deflection, whatever the sleeve movement is there. So two type of questions they will be asking, a basic questions, right? So that questions has been already been asked in engineering services prelims, right? So GATE has not touched this. GATE has not touched this particular topic. So definitely in this year they can touch from this Hartnell governor. So let's suppose this is the arms. Two arms are there for the governor. Let's suppose I'm naming them as A and B, right? Now there are two positions. There are two positions. First position is will be what, the maximum position and the minimum positions, right? Maximum position basically correspond to maximum speed of rotation, and the minimum speed minimum position correspond to minimum speed of rotation. Like this we are defining. Okay, so first of all we are considering the maximum position corresponding to what? Corresponding to maximum speed of rotation. Okay, see, it is a rigid arm. Consider A and B as a rigid arm. So obviously angle between both this link will be always 90 degree. It is a rigid arm, right? Now carefully observe. So if it is a moving at a maximum speed, so it will be like this and it will be like this, right? Okay, now please understand this particular point, that this is what R1 I am considering, and this is what simply R, right? Clear? Now second term, for a low speed, for low speed it will be like this. Now see, it will be what, R2, it will be what, R2, here it is R, it is R2, right? Now what are these things, what are these things? Movement of sleeve, na, movement of sleeve, H1 H2, these are nothing but the movement of sleeve, this is nothing but the movement of sleeve, right? Now please carefully observe, please mention, first of all mention this particular point, R1 is nothing but the radius of rotation corresponding to maximum speed of rotation, maximum speed of rotation, right? R2, radius of rotation corresponding to minimum speed of rotation, minimum speed of rotation. Yes, everyone, each and everyone, the diagram is clear to everybody, the diagram is clear to everybody, guys tell me, yes guys tell me, the diagram is clear to everybody? Okay, each and everyone, it is clear? Great, great. Now see, at this position, let's suppose I am considering this point as O. So I will be taking the moments about A, about O basically. This particular point I will be taking the moments. What are the parameters are there which will be involved in calculating the moment about O? See, first one will be the centrifugal force. Obviously a centrifugal force will be there at the balls, right? Another term will be what, the mass of sleeve including the friction. Oh, we will not consider the friction here, we will consider the spring force here. We'll consider the spring force. So mass of sleeve plus spring force we have to consider here, okay, because it is spring control, na? So spring force will be acting here. So with the mass of sleeve we have to include what, the spring force basically, you have to include the spring force. So how you can write, see, please carefully observe how you can write, okay. So first of all, FC1, centrifugal force for the location 1. Location 1 basically one point corresponding to the maximum speed of rotation, right? So I have to say it will be the FC1 centrifugal force for the position 1. Position 1 correspond to maximum speed of rotation. Position 2 consider for corresponding to minimum speed of rotation. So FC1 is there. So if I have to take the moment about O, if I have to take the moment about O, I will be taking the value of A only. Why? Because this theta, right? See, this theta is very less, very less. So I can directly multiply FC1 with A, right? FC1 with A, and it will be equals to what? It will be equals to what? Mg plus Fs1 divided by 2 multiplied by B, right? This is the equation that you need to remember, right? I've taken the moment of centrifugal force about this point by multiplying the A distance, okay. Actually I have not considered this theta, actually I have assumed this theta is very less, so I have just taken the value of this length only, I have not taken this value, because actually what you have to do is, na, you have to take this thing, this will be the actual length. So A cos theta will be there, but as the cos theta is very less, it will be close to 1, it will be close to 1, that's why I have taken A only. Clear? It is clear. So in the similar way you can write another equation like this, FC2 into A equals to Mg plus Fs2 divided by 2 into B. Like this you can write. Clear? Each and everyone. This is clear. These two equations are very important. Great. Now just subtract both the things, both the equations. Let's suppose I am writing equation 1 and 2. This is equation 1, this is equation 2. Just subtract both the equations. What you will get? See, Fc1 minus Fc2. We'll take the A common. So A is common, so we'll take A common. Here Fs1 minus Fs2 divided by 2 into B. B is common here, okay. In the right hand side B is common, okay, 2 is common, right. So we'll take it. Now please see that we have to take Fs1 minus Fs2, 2 into A by B, Fc1 minus Fc2. See, it will be very easy to calculate Fc1, Fc2 because m r omega na, simply. Fc1 will be what? mr1 omega 1 square. Fc2 mr2 omega 2 square. Like this the things will be there, okay. Now please carefully observe that Fs1 minus Fs2 can be written like this: K, stiffness multiplied by the movement of the sleeve, right. Like this you can write. Like this you can write. So delta is what? Sleeve movement. Delta is what? The sleeve movement. And what will be the sleeve movement? Please carefully observe. H1 plus H2 will be the sleeve movement. H1 plus H2 will be the sleeve movement. But how to calculate H1 and H2? See, for that I am considering this theta, okay. For this theta I can write it like this. Please see. Let's suppose I am assuming the tan theta term. So if I use the tan theta term, it will be what? H1 by B, okay. Whatever the theta has been there, same theta will be there, okay. Actually this vertical and horizontal were the initial conditions, right. Let's suppose after this initial condition it come to the maximum condition. So when the maximum condition is there na, so this horizontal has turned theta and similarly this vertical has turned theta, so both thetas will be equal. So how we can write? Just take perpendicular upon base, right. In this case also perpendicular upon base. Similar way, just a similar way you have to write. What is the perpendicular? It will be what? R1 minus R you have to write, divided by base what? A, okay. So H1 is nothing but A by B R1 minus R, right. In the similar way we can also write S2. In the similar way we can also write S2 here, okay. We'll write S2 here. Now see how we can write S2. Just consider this particular thing. Again vertical and horizontal. For the mean it is what? Vertical and horizontal what? Initial position. But if we consider the mean minimum position, right, that is what? 2 correspond to minimum position. It will turn into theta. Similarly vertical will also turn theta. So in the similar way we'll write S2 divided by B. We'll write S2 divided by B perpendicular upon base like this. And here also perpendicular will be what? R minus R2 divided by base A, divided by base A, okay. So from this you can write S2 equals to what? B by A, okay, B by A R minus R2. Clear? It is clear everyone? Tell me fast. It is clear? Each and everyone? It is clear? Okay. So here also it is B by A, not A by B. Please correct it this one, because B will be multiplied here na, so it will be B by A. So these terms are important. These terms are important here. So we will get the H1 value and H2 value. We will be utilizing the H1 and H2 here. So please observe H1 plus H2. What is the value of H1? What is the value of H1? B by A R minus R1 minus R, right? And here it will be B by A R minus R2, right? Like this. So if you solve, you will get what? B by A multiplied by R1 minus R2, like this. Just you need to put this particular value here. Just you need to put the value of delta here. You will be getting what? The stiffness. We will be getting the stiffness. So directly you need to remember the formula of stiffness. Hi Pragya. Okay. So see, please carefully observe this particular thing. K delta is there, na? This particular formula. K delta 2 A by B FC1 minus FC2. Clear? So FC1 minus FC2, the formulas you know, FC1 and FC2 you know already. Now please carefully observe. So we'll just put the value of delta here. So 2, what is the value of delta? Delta value is B by A. So if you put the value here, it will become what? A by B square here and FC1 minus FC2 divided R1 minus R2. So this is the formula that you need to remember always, right? From the gate point of view, directly this formula will help you, okay? Because if you remember this particular formula, a lot of time will be saved. You don't need to do all the analysis part, okay? You don't need to do all the analysis, and obviously if you do that particular analysis, a lot of time will be wasted. A lot of time will be wasted, okay? Just remember this particular formula for the Hartnell governor, and it is very important. For sure you will see a question from this particular topic, or this formula will be used in the Hartnell governor for sure, okay? So very important for the GATE 2020 examination. Please carefully observe, okay? All of those things is clear to you, everyone? It is clear? Guys, tell me first, each and everyone, it is clear, everybody? So we have discussed what? The Hartnell governor, we have discussed Proell governor, we have discussed the Porter governor, we have discussed the Watt governor, and we have also discussed the basic operation of the governor, right? The basic part, the mechanism, what is the operation, how the load increasing, when the load increase, speed decrease, the sleeve moves downward, and when it moves downward, throttle opening will be there. Whatever the throttle opening is there, it will increase, okay? And if the throttle opening is increasing, fuel supply will be increasing, and when fuel supply increasing, power will be developing at a higher rate. So whatever the power is increased, that will be used to balance the increment in the load. Clear? Yes, clear. Okay, thank you so much. So I think governor part is clear, everyone. Yes, governor part is clear. Now next important topic is what? The gyroscope, guys. Very important. One important formula is there in the gyroscope, but lot of understanding of a gyroscope is there. Lot of understanding is required in gyroscope. Actually in the calculation part, only one formula is there. Everyone knows the formula, but most of the students will do a mistake here there. In what sense they are doing mistakes? They are doing a mistake in the sign conventions that you are using in the gyroscope, okay? Formula is what? I equals to, if I talk about the gyroscopic couple formula, I equals to couple equals to I multiplied by omega s into omega p. Formula is very simple, everyone knows, but still most of the students will do the mistake, okay? We'll discuss the topic of gyroscopic couple in detail, okay? It is very easy, but please you have to be very sure that this formula, just formula is not needed, okay? Behind the formula, what are the logics are there, okay? That is also important. Right? Just wait a minute, we'll start the gyroscope part. Okay guys, so see, first of all you need to understand some basic part. Okay? So let's suppose this is the rotor. Please carefully observe. This is the rotor, okay? This is your rotor which is rotating in what? Anti-clockwise sense. But how I am saying it is anti-clockwise? See, because when I view this particular, when I am seeing this particular rotor in the right hand side, from the right hand side, if I am observing this rotor, it is moving in anti-clockwise sense, na? See, this is the RHS, right hand side, and let's suppose this is the left hand side. So let's suppose from here, if I am watching this particular rotor, if I am seeing this particular rotor, definitely it will be considered as the clockwise rotation, right? It will be considered as clockwise from LHS, but from RHS it is considered as anti-clockwise. So always there will be a confusion. Someone say it is clockwise, someone say anti-clockwise, right? Okay, clear? So please careful. Gyroscope is a effect. It is a effect. See, we'll discuss that also, but first of all, understand the basic part, how this effect is coming into the picture. How this effect is coming into the picture, that is very important to understand. We'll discuss the application part as well, but first of all, understand how this effect is coming into picture. Okay. Now, first of all, are you getting the point? There is a difficulty when we say rotation as a clock, anti-clock. There is a difficulty because someone will say anti-clock, someone will say clock, because in the left hand side it is clock and from right hand side it is anti-clock. So actually we'll use a vector method to define the rotation. We'll use a right hand thumb rule. We'll use a right hand thumb rule. See, we'll use a right hand thumb rule. See, it is moving in anti-clockwise sense, so just use the right hand thumb rule. Okay, we'll use the right hand thumb rule. See, just curl your fingers, in the sense of rotation. So it is an anti-clockwise, from the right hand side I am observing now. So it is an anti-clockwise sense. So this thumb will represent the direction of rotation. This thumb will represent the direction of rotation. So thumb is towards right direction. Now please see from the left hand side as well. From the left hand side it is what? Clockwise. So fingers, my fingers are curled in clockwise sense, but the thumb is again in the right hand side. Now clear? So we can say for this vector will be in the right hand side. Vector will be in the right hand side. The direction of movement, we can say, direction of rotation, we can say like this. Vector pointing towards right hand side. Vector pointing toward right hand side. This is the vector for this rotation of a rotor. Whatever the rotation of a rotor is there, we can define like this. So this vector is representing the rotation of a rotor. I hope this is clear. So we'll not use clock, anti-clock, we'll just use a vector for representing the rotation of anything. Clear, each and everyone? Now, first of all, see, you have to understand the plane names. See, this particular plane will be called as XY plane. Okay, this particular plane will be known as YZ plane, and this particular plane is known as XZ plane. Okay, this XZ plane is what? Horizontal plane. Clear? The horizontal plane will be what? The XZ plane. The vertical plane will be what? XY plane. This plane is clear to everybody how we are naming the planes. We can also name in a different way also. XY plane is also known as what? Z plane. Right? XZ plane is also known as what? Y plane. And YZ plane is also known as X plane. Clear? See, tell me first, this particular basic concept is clear, how we are naming the different planes? Yes or no? How we are naming the different planes, it is clear to everybody. Okay. And how we are defining the vector for the rotation, because vector is very important to define the rotation. Okay, again please remember, we have defined the direction of rotation. We have defined direction of rotation with the help of right hand thumb rule. Right hand thumb rule. Clear? Super. Okay, great. So now the direction of a rotation with the help of right hand thumb rule, it is clear to everybody. Now what will happen? See, so this rotor is rotating in anti-clockwise sense from right hand side, and this is a vector we are representing for the rotation. Now let us suppose this is your rotor. Let's suppose this is the shaft on which rotor is lying. Okay, so this is the shaft. Okay, consider my hand as a shaft, and on this shaft a rotor is mounted, right, and it is moving in the anti-clockwise sense from right hand side. Now let's suppose this shaft moves in this way, horizontal. It is what? Horizontal plane, right? This shaft is moving like this. Okay, it is moving like this. Okay, so there is a movement, or there is what we can say angular movement in the axis of rotation. On, we can say, see, first of all, please understand this thing. This is what axis of rotation, or spin. Now what is happening? Axis of rotation is moving. Axis of rotation is moving. Okay, there is some angular movement in the axis of rotation or axis of spin, and because of which you will see the gyroscopic effect. You will see a gyroscopic effect. Okay, clear? So how it can be possible? See, let's suppose a airplane is there, a propeller shaft will be there, which is rotating. Now let's suppose if you take a left turn or a right turn, if you take a left turn or right turn, what will happen? See, this is propeller shaft of a plane. It is rotating. Okay, it is rotating. But let's suppose if you take a left turn, or you can take a right turn, right? You can left or right. In this way you can take. So if you take a left turn or right turn, the axis of rotation is having an angular movement. Axis of rotation is having angular movement, right? Because of which a gyroscopic effect will be there. Okay. Now see. Now, as we have said, let's suppose this is what the horizontal plane is there. Let's suppose now are you getting the point? All of these things will be happening in the horizontal plane, right? So this axis of a rotation has an angular movement. In the horizontal plane itself, it is moving in the horizontal plane itself, but towards left, or it can move in towards right also. But because of this gyroscopic effect will come into picture, right? This is clear, each and everyone, this is clear. So see, please carefully observe. So as you all know, this effect is in the horizontal plane, this effect is in the horizontal plane, right? So let us suppose if I am drawing the horizontal plane, because all of these things are happening in horizontal plane, na? So let's suppose this is the horizontal plane. Please assume this as a horizontal plane, right? Please assume this as an horizontal plane. Okay. So initially the axis of rotation is like this, and if I put the arrow, so this is what axis of rotation. Okay, I have put the arrow because it is the anti-clockwise and right hand side. From right hand side it is anti-clockwise, and if I use the thumb rule, the arrow will be towards right, right? So this is the vector representing the rotation of axis, right? Assume this plane as a horizontal plane. This square box is nothing but the horizontal plane itself, right? So in the horizontal it is moving toward left. So obviously if it is moving toward left, please carefully observe, so it will be like this. Clear? It will be like this. Now the vector will be like this. Okay. Now if you see, some effect will be there, because of which it has angularly displaced. That is known as active gyroscopic couple. That is known as active gyroscopic couple. This is known as active gyroscopic couple. And because of the reaction effects, like this, it is known as what? A reactive gyroscopic couple. Reactive gyroscopic couple. Now tell me, it is clear? Yes or no? It is clear to everybody? Guys, tell me first. It is clear? Tell me fast, it is clear? So this all of those things are happening in a horizontal plane itself, right? Now please carefully observe, this is what active gyroscopic couple and this is what a reactive gyroscopic couple. But please observe that it is in the horizontal plane. This diagram is of the horizontal plane itself, right? Now consider this arrow and please use your thumb to which is pointing towards the arrow, right? Please use your thumb so that you can use like this. See, if you put your thumb like this, so it will be acting in the downward direction. In the downward direction, please use consider the fingers. Please consider your fingers. It is having what? It is having an effect of downward effect from the rear and upward effect from the front, right? Are you getting my point? Now tell me, are you getting this? See, use your right hand, please use your right hand, okay? Right hand will be like this because this thumb is pointing towards the arrow, right, like this, and use your curl. And if you see the curls, it will be pushing the rear end in the downward direction and the front end in the upward direction. Clear? Clear? This is important, right? Again, very important. So if I draw a diagram here, please carefully observe. Like this you are having, okay, great. Now see, okay, like this you are having the planes. Okay, clear, each and everyone, these planes are clear to you. Now please observe what actually happens. See, let's suppose this is the shaft or this is the axis you are having. This is the axis of rotation is there or vector which is representing the rotation, right? This is in the horizontal plane like this. Now it is taking a left turn, okay. Please carefully observe, this is like this because it is taking a left turn. So it is taking a left turn, so obviously there will be some gyroscopic couple will be there, right, like this. And because of this active gyroscopic couple, there will be a reaction which is known as reactive gyroscopic couple, like this. A reactive gyroscopic couple will be there, okay. So please remember the names. Reactive couple and it is what? Active gyroscopic couple. Okay, clear. But we want to see what are the effects of reactive gyroscopic couple. We want to see what are the effects of reactive gyroscopic couple. Okay. Now, please carefully observe. So all of those things are happening in horizontal plane. Okay, correct. Now, see. So in the horizontal plane, see, this arrow is like this. Okay, in the horizontal plane, it is like this. And please consider the fingers, curl. The fingers is pointing the back direction towards the downward direction. It is this curls putting the backward direction or the rear end in the downward and the front part in the upward direction, right? Because of this curls, we are getting this feeling na, that back or the rear end is going in the downward direction and the front part is going upward. So this is the feeling we are getting from the right hand thumb rule. Clear? Because all of those things are happening in the horizontal plane. That's why we have put our thumb like this. If let's suppose it is happening in the front plane or in the vertical plane, we'll consider the thumb like this. But it is happening in the horizontal plane now. All these things are happening in the horizontal plane. That's why we are considering the horizontal plane and we have put our thumb like this, right? So this is the horizontal plane. Clear? Each and everyone, this is clear. Formula is very easy, guys. Formula everyone knows. I omega omega p, omega s omega p. See, please carefully note that omega s is what? Angular speed of, directly I can write the directly formula 2 pi n by 60. Whatever the speed of rotation is there, correspondingly angular velocity will be there. Omega s, angular velocity of the spin or the rotation. What is omega p? Angular velocity of the precision, v by r. V by r. What is the angular velocity of precision? See, please carefully observe a very important point here. First of all, consider this particular thing. In whatever axis the rotation is there, that particular axis will be known as axis of rotation. Clear? Axis of precision will be that axis about which the axis of spin is rotating. Right? Let's suppose this is your shaft and it is rotating. So this axis is nothing but your axis of rotation or axis of spin. But let's suppose this axis of spin is rotating like this or like this. Okay. So it is moving with respect to what? This vertical axis, right? Which is known as axis of precision. So let's suppose if axis of shaft or axis of rotation or axis of spin, we can say, if it is moving, then we can say it is moving with respect to axis of precision. Okay. Which forces is responsible to develop the active couple? See, Pragya, see, consider. This is your plane, right? This is your plane which is moving. This is plane. Aeroplane you can consider, a simple aeroplane. A propeller shaft will be there in the aeroplane. So it is rotating, right? Now, if you take a right turn, it is applied by you only. It is applied by you only. You have taken the right turn. So shaft will be turned towards left. That is what active gyroscopic couple. And from the active gyroscopic couple, you will see a reactive gyroscopic couple is also acting. Right? Okay. See, please carefully observe that this axis, first of all, this axis, what? Axis of rotation. Now, please consider this particular point very carefully. This axis can be turned like this, or like this. See, this axis is rotating, na? This axis is rotating. Okay, this is the propeller shaft. It is rotating like this. But this shaft can also move like this. While in rotation, it can move like this, like this. In the horizontal plane, it can move. In the vertical plane, it can move. Right? It is clear, na? The shaft which is rotating like this can move horizontally, can move vertically. So when it is moving horizontally, this particular axis will be what? Known as axis of precision. Axis of precision is that axis about which axis of spin or axis of rotation is moving. Clear? So we are applying this active couple, right? We are actually applying. Okay. So this is the horizontal plane. Okay. So omega s, omega p, you know, this is the formula. Very easy. Direct magnitude, whatever the magnitudes are there, you can apply. So you will get the answer. Magnitude you can get. But what are the effects of this reactive gyroscopic couple, that we need to understand very carefully. Now, so we have taken this case now. So again, just consider this point. Again, last one more diagram that we need to understand. This is x, this is y. Okay, and your rotor is like this. And rotor is having like this motion. Okay, clear. So we can say this is axis of rotation. or axis of spin as well we can say. Now this axis is moving like this, so it is moving. How it is moving? How it is moving? Because this axis, I see, please carefully, this vertical axis has turned, right? Please carefully observe this particular point, very important. This horizontal axis is what? Axis of spin. If it is rotating like this, clock, anti-clock, like this, so about which axis it is moving? This vertical axis, na? About this vertical axis it is moving right, left in a horizontal plane. So this axis is known as what? Axis of precision. Clear? Each and everyone, please tell me first. This axis is rotating. The shaft is rotating like this. Now, if you rotate this shaft like this, if you give angular displacement like this in a horizontal plane, so if you give a movement, horizontal movement like this to a shaft, so about which axis it is rotating, we can say this vertical axis, na? This vertical axis, about this vertical axis it is moving like this, right? Now if you are saying, let's suppose sir, it is not moving in a horizontal plane but it is moving in a vertical plane like this, shaft is rotating. This is one important parameter, it is already there, rotation is there, but axis is moving up and down, so it will be rotating about this particular axis. So axis of precision can be changed. It is not like that it is always the axis of precision for all cases. Not, it is not the case. Axis of precision can be like this. Axis of precision can be like this, na? No. Now consider this point. Now when we said it is moving like this, so this axis known as axis of precision. Now if this axis of spin is moving like this, so this axis perpendicular to the plane of board, will be known as what? Axis of precision, because the shaft is going up and down with respect to what axis? This axis. Clear? Each and everyone. So first you have defined axis of a spin, axis of precision will be given to you, and the remaining third will be what? Axis of gyroscopic couple. The third one will be known as axis of gyroscopic couple. Right? So please carefully observe. Axis of spin will be given to you, axis of precision will be given to you, and third one automatically becomes axis of gyroscopic couple. Now we'll apply these concepts on what? Aeroplane, from which you will definitely some questions. Okay, consider the case of aeroplane. Okay guys, please see. Let's suppose this is the aeroplane, okay, and please consider this as a rear end, this is front end, and actually this rear and front is also known as what? This is nose, this is tail. Clear? Now yes, yes, z axis, correct. Now consider the case in which they are saying like this: propeller shaft is rotating clockwise from rear end. Let's suppose they have given like this, from rear end. Okay, propeller shaft is rotating clockwise from rear end, they have mentioned like this. Okay, and they have mentioned, okay, and they have mentioned aeroplane takes left turn. So aeroplane is taking the left turn, right? Aeroplane is taking a left turn. Please carefully observe this particular case. If this case is clear to you, then every case you can answer. From every case you can answer, right? If this case is clear to you, then every case will be easy for you. So propeller shaft is there. They have mentioned a propeller shaft, right? So let's suppose this is the propeller shaft. Okay, clear? So they have mentioned the propeller shaft is rotating clockwise from rear end. So from rear end clockwise will be like this, curls will be like this, curls will be like this, and the thumb will be towards this direction. So I have first of all I have defined what? The vector for the rotation. First of all, we have to define the vector for rotation. Now they have said it is taking a left turn. It is taking a left turn. So obviously left turn will be like this. Left turn will be like this. Okay, great. So obviously our active gyroscopic couple has been acted. This is active gyroscopic couple, and for this active gyroscopic couple there will be a reactive gyroscopic couple. Pranjali Sharma, nose up, tail down. Okay, we'll see that. See, this is what reactive gyroscopic couple. Now all of these things are happening in a horizontal plane. All of those things, whatever the things are there, these are happening in the horizontal plane. See the direction, the thumb will be like this, and it is what? The fingers. Now see your thumb, it is towards like this, and see your what? Your fingers. Fingers pointing towards the rear end, and it is putting in the downward direction. See, fingers have an effect on the rear end as it is moving in downward direction, and the tail part, or we can say rear, actually both are same, right? Rear and tail both are same. Actually, if this fingers focusing on what? Putting these things in the downward direction, right? And nose part in the upward direction, and the nose part in the upward direction. Yes, Pragya, yes, Pranjali, yes, absolutely correct. Nose will be what? Up, tail will be down. Nose will be up and tail will be down. Ekant Singh, hello, yes. Ekant, hello. So it will be what? See, effect of this gyroscopic couple will be like this, right? This arrow is pointing the tail towards in the downward direction, right? So we can say, so let's suppose this is your propeller shaft. Now how it will be there? It will be like this now. So we can say tail part has down and nose part has gone up. This is clear? This is clear? Tell me. Ekant, it is clear to you? Ekant, it is clear to you? Everyone, it is clear? So this is the reactive gyroscopic couple. So this is the effect. How we are mentioning this effect? With the help of curls, right? With the help of curls we are defining this effect. So effect will be what? Tail part goes down and up part will be what? The nose part will go up. This is the result. So first of all you have to define, first step is what? Just define the vector for the axis of spin or axis of rotation. First define the vector for axis of rotation. After that, please see where the motion is there. Axis of spin is rotating in what sense? So they have mentioned airplane takes the left turn. So it is taking a left turn. So this axis is moving like this. So because of this motion, active gyroscopic couple will be there and reactive gyroscopic couple will be there. Clear? This particular case. Another case, just we can take the opposite case also. Just opposite case we can take, a very simple one. Let's suppose again this is your aeroplane. Consider this as your aeroplane. Okay. Rear and front. Okay, they can give any rear end or front end. They can give anything. Okay. So let's suppose they have mentioned in this question, they have mentioned like this: propeller shaft rotating in clockwise when viewed from front end, right? Please carefully observe this particular thing. Carefully observe this particular thing. Propeller shaft rotating in clockwise sense when viewed from front end. So when you are seeing this particular airplane from the front part, it is propeller shaft is in clockwise sense, right? Okay, let aeroplane takes right turn, takes a right turn. Now tell me the answer, guys, fast. Tell me the answer. So clockwise, okay, clockwise will be like this. From front end you are seeing, na, from the front part you are watching this particular airplane. From the front part you are seeing this particular airplane, na. So clockwise sense, thumb will be pointing towards left. Thumb will be pointing towards left. So it will be like this. Okay. Now, as they have mentioned, aeroplane takes the right turn. Aeroplane takes the right turn. So when the aeroplane takes the right turn, it will be like this. Aeroplane, when the aeroplane takes the right turn, right? So when aeroplane takes the right turn, this is what the active gyroscopic couple, and there will be what, a reactive gyroscopic couple like this. And because of this reactive gyroscopic couple, what will be the effect? What will be the effect? Same as previous. Again, please carefully observe. Everyone tell me fast. See arrow, please see the arrow. In this particular case, what will happen? See, please carefully observe that the propeller shaft, they have mentioned what? The propeller shaft rotating in clockwise sense. Now, rotating in clockwise sense means what? Rotating in clockwise sense means towards the right hand side. The vector will be pointing towards right. Vector will be pointing towards right. Okay, clear? Vector is moving, the direction of vector will be pointing towards right. Okay, clear? Now, they have mentioned that you are watching from the what front end. Okay, clear. Now aeroplane takes the right turn. Aeroplane takes the right turn. So now when the aeroplane will take a right turn, sir, right turn, Pranjali Sharma, you're talking about the right turn. Yes, it is mentioned that it is a right turn, na? Yes, they have mentioned the right turn. Yes, correct. What is your doubt, Pranjali? What is your doubt here? What is your doubt? Please mention your doubt. Rear will go opposite. No, see, actually in the front part you are saying it is a clockwise, okay, it is clockwise. So definitely from the rear part it will be what, anti-clockwise. So from the rear part it will be anti-clockwise. So direction of thumb will be here only. Direction of thumb will be here only. Direction of thumb will be here only, right now. So front from clockwise, anti-clockwise from the rear. So if you take the anti-clockwise sense of a curl, the thumb will be pointing towards like this. So this direction is clear. This direction is correct. This direction is correct. Now they are saying it is having a right turn. It is having a right turn. Right. Now they are saying it is having a right turn. So right turn will be what? See, this is the plane. Na? When it takes a right turn, it will be like this. Okay, it will be like this, na? Or it will be like this. It will be like this. Okay, it will be like this. Right turn. See, obviously the plane is like this. Whatever the axis is there, because of the rotation, right? But the plane is like this. If it is taking a right turn, it will be like this. Okay, clear? Yes or no? It is clear? See, in the previous case as well, please carefully observe. They have said the propeller shaft, see, previous case again we will see, in the propeller shaft rotating clockwise from the rear end, okay, clockwise, so thumb will be like this, okay. Now airplane takes the left turn, so this is your aeroplane, it is taking a left turn, so when it is taking a left turn, it will be like this. When it is taking a right turn, it will be like this. But vector should go left. But vector should go left. Okay, see, this is left, this is right, right? So, okay, yes, Pranjali, you are saying correct. You are saying that, yes, it goes towards left direction. If we are talking about the right, yes, you are correct, absolutely correct. See, it will be like this, and see, this is active and this will be what? Reactive. And effect of reactive will be what? Like this, right? Effect of reactive will be like this. Again, same answer will be there, yes, absolutely, Pranji, absolutely correct. So this is your X propeller shaft. Now it is like this, so we can say tail down, nose up. Correct, absolutely correct, superb, yes, absolutely correct. Okay, clear everyone, it is clear, the doubt is clear to everybody, great, superb. Okay, because it is taking a right turn, so when we take about the vectors now, it will take in a left direction. Thank you, Pran, thank you so much, right? So this is for the aeroplane. So if this case is clear to you, every case you can solve on it your own. Okay, now most important part is what? The next, ships. In the ship's case, you need to understand some terminology. In the ship case, you need to understand some important terminologies. What are those terminologies? See, this is the front view of a ship. This is the front view of the ship. So this particular part is known as bow or fore, and this particular part is known as stern or aft. Okay, so this is the front view. But from the top view, when you see the ship from the top, okay, when you see the ship from the top, it will be like this. Now, when you see a longitudinal axis, this axis is known as the longitudinal axis, and perpendicular to the longitudinal there will be a transverse axis, right? Okay, so carefully observe the name port and starboard. Okay, port and starboard, these names should be clear to you, right? So when you are moving towards left, you will say it is moving towards port. When you are moving towards right, you will say starboard. So actually this is the top view, na? From the top you can say it is moving right and left. Okay, from the top view you can say it is moving right or left, like this you can say. Great. Now three things are there here, three things. First of all, steering, pitching, then third one is rolling. Now tell me first about steering. When we say steering, what actually mean? What do you mean by the steering? First of all, tell me, what do you mean by steering? What the term steering will represent in this case of ship? What does actually steering represent? Tell me fast. And what pitching is there when we say in the case of ships? Tell me. What do you mean by steering? What do you mean by steering? Left, right. Yes, absolutely correct. Absolutely correct. But when you say pitching, it means that when you say pitching, what do you mean by pitching case? What do you mean by pitching case? Pitching case will be like this. See, for the steering you have said na, right and left. Pitching case will be up and down like this. Yes, exactly correct, Pranjali. Yes, absolutely correct. Now, we need to understand what the gyroscopic effect in steering. The steering case is exactly similar to the aeroplane case. How? See, just you need to understand this particular point. This is x, y, this is z, this is x, right? Now, let's suppose steering case is there. So now they will say your ship is moving towards left or right. So actually in place of left and right, they can also say it is moving towards port or it is moving towards starboard. So you need to remember this term port, it is towards left, and towards right it is starboard. This term you need to remember, right? So let's suppose they say propeller shaft is rotating in what? Clockwise sense from the rear end. Okay, from the rear end. So rear end will be known as what? The stern, and the front part will be known as what? Bow. Okay, remember these things. Front part and this is your rear part. So from the rear and front they will say the sense of rotation. The sense of rotation they will give from the rear and front. Okay. Let's suppose they will give a stern. They will say when you view a ship from the stern part or the rear part, propeller shaft is rotating in clockwise sense. And if it is in rotating in clockwise sense, the vector will be towards right. The rotation vector will be towards right. Clear? Rotation vector will be towards right. Now if they say the ship is moving towards the port. Ship is moving towards port. What is the effect? What will be the effect? Ship is moving towards port. What will be the effect? Tell me fast. Propeller shaft, when you see a ship from the stern, from the rear part, shaft is rotating, propeller shaft is rotating in clockwise sense, thumb will be towards right. So this is the thumb for the rotation. Now they are saying ship is moving towards the port side. The ship is moving towards port side. So what will be the effect for this? What will be the effect, guys? Tell me fast. What will be the effect? What will be the effect? Fast. Tell me fast. What will be the effect when you consider the steering part? Bow up, stern down. Yes, absolutely correct. Bow will be up and stern part will be down. Correct. Absolutely correct. So it is similar to the aeroplane case that we have discussed, right? The similar case. Steering case will be similar to the aeroplane case. Now come to the pitching part. It is important. Now come to the pitching part. It is important to understand. See, in the steering part, the precision, so your axis of spin is rotating in clockwise in the horizontal plane itself, right? Please consider this point. When you consider the steering part, your axis of spin or axis of rotation is moving in horizontal plane. But when we talk about the pitching, it is moving in vertical plane. Okay, it is moving in vertical plane. So first of all, we'll draw this vertical and horizontal plane. Like this. So pitching, in case of pitching, your shaft is moving up and down. So movement of a shaft is in vertical plane. So we'll draw the changes, whatever the changes are there in the vertical plane itself, right? Now please carefully observe. This is your shaft. Again I am considering the same case. Propeller shaft is rotating clockwise from the rear end. Okay, so vector will be like this. Vector will be like this. Now consider this case. Pitching is there. Pitching in the upward direction. Pitch upward, movement in the upward direction. So it will be like this. So in case of pitching, two things are there. Na? Either it will go up, either it will go down. Right. So let's suppose it is going up. So this is the case. Now please understand this point. This is active. This is reactive. And what is the effect of reactive? Tell me fast. What is the effect of reactive? What is the effect of reactive? Effect of reactive will be what? Effect of reactive couple. Tell me. Effect of reactive couple. Tell me fast, guys. Everyone, each and everyone. Tell me the effect of reactive couple. Effect of reactive gyroscopic couple. What will be the effect? See, all those things are happening in the vertical plane. Now, you have to use your thumb in the vertical plane. Na? So, the direction will be in the downward. So, your fingers will represent what? The curl, the movement of this finger will represent you what? Turn towards starboard. Yes, absolutely correct. See, when you see your thumb, na, fingers will be like this. It is taking a turn. So actually, while pitching, the effect will be what? Steering. Effect will be what? Steering. Right? Effect will be what? Steering. So here we'll say steer towards starboard. This is the effect. Clear? Steer towards starboard. Clear? This is the effect of reactive gyroscopic couple. Just you need to put your thumb in the vertical plane and see the fingers, in what direction fingers are moving. Okay, so it is like this. Let's suppose if it is pitching downwards, so in that case the reactive gyroscopic couple will be upwards, and your fingers will be moving towards what? Towards the port size, towards the port, right? Towards the port, because here it is moving towards starboard, and in the pitching downward case it will be moving towards the port. Clear? This is clear. So you need to remember this port word, starboard word, this turn, this bow, these terminologies are important, right? Now, okay, now tell me, what about the rolling? In case of rolling, what will be the gyroscopic effect? In case of rolling, what will be the gyroscopic effect? Tell me fast. In case of rolling, what will be the effect of gyroscopic couple? Will there be any gyroscopic couple in case of rolling? No effect. Yes, correct. Correct, Pranjali. Yes, absolutely. Why? Because if you consider the rolling, both the planes are same, direction is same. So how can be this gyroscopic effect will be there? No gyroscopic effect in case of rolling. Please remember this particular case. Okay, very important. Either they will ask from the ship or they will ask from this aeroplane part, right? But this is the basic that you need to understand, right? This is the basic part that you need to understand. Okay, and this formula is very simple. Everyone knows the simple formula: I omega s omega p. Omega s axis of rotation of rotor, or whatever the propeller shaft is there, rotational speed of rotor, and precision angular speed, right? V by r, by the formula, by V by r formula you can calculate omega p. Now moving to the next part, that is what? Balancing. Next part, we'll move to the next part, that is what? The balancing. Okay, this is again a very basic, very simple topic. Just you need to apply your engineering mechanics concept. Very, very easy, right? Very easy. See, when we talk about the balancing, two things are there: revolving masses and the reciprocating masses. Remember this thing. Revolving mass and reciprocating mass. Okay. Now, please consider these things. First of all, you need to understand what are the important parameters in revolving masses and reciprocating masses. First of all, what is the unbalanced mass? mr omega square. This is the unbalanced force basically in revolving masses. The centrifugal force, basically the centrifugal force, right? We can say here the unbalanced mass will be what? mr omega square. Correct? But what are the important things about this revolving masses? When we want to balance this revolving mass, two things are there: magnitude and direction. If you talk about magnitude, and if we talk about the direction, see, magnitude is what? Changing. Sorry, magnitude is what here is constant, but direction is what? Changing. Okay. See, in case of reciprocating masses, there is one unbalanced force is there. Mass into acceleration, mass into acceleration. Acceleration of a slider. You remember in the slider crank mechanism, we have discussed the acceleration also. R omega square cos theta plus cos 2 theta by n. N is what? Ratio of L by R. Now, please see, magnitude and direction, two things are important. Magnitude is what? Because as the theta changes, so obviously magnitude will change. Magnitude will change. Right? Direction, it is constant. So please remember this important points, that if you want to balance revolving masses, the complete balancing is possible here. Is possible, but here complete balancing not possible. Complete balancing is not possible. Clear? Each and everyone. So first of all, you need to understand the magnitude of a reciprocating. If you want to balance the reciprocating mass, what is the problem? The magnitude is changing. As the theta is changing, the magnitude is changing. So magnitude is not constant. Yes, direction is constant, but magnitude is not constant. In revolving masses, magnitude is constant, but direction is not constant. So revolving masses, in case of revolving masses, you can completely balance, but in case of reciprocating masses, you cannot completely balance the reciprocating masses. Right? This is clear. Any doubt? Any doubt? Any confusion up to this point? Tell me first. Tell me. Any doubt, any confusions? Okay. So we'll discuss first of all the balancing of revolving masses. We'll discuss the balancing of revolving masses. Okay, clear. So we'll write out the balancing of revolving masses. Okay, direct formula based relations you need to understand, and it is very easy. Whatever the question you have, whatever the question the gate has asked up to this point from this particular topic, balancing, it is very easy. Just the basic engineering mechanics concept is required to solve those questions. Okay, just basic engineering mechanics concept is required, right? Okay. So actually, while we balance the revolving masses, two cases are there. The first part is what? The static balancing. Second one will be known as the dynamic balancing. See, when we say static balancing, the condition will be what? F net will be 0. But when we say dynamic balancing, F net, apart from F net, M net, that is net moment, should also be 0. Okay. These conditions you need to understand. Net force should be 0, obviously in both the cases, but apart from the net force, moment should also be 0 in dynamic balancing. In dynamic balancing, correct? See, in static balancing, net force should be 0, but for a completely balanced system, both balancing, dynamic balancing should be there. Dynamic balancing should be there. So we'll consider the case C, single mass, single revolving mass. We'll consider first case as a single revolving mass. Single revolving mass we'll consider. Okay, correct? Now see. Okay. So let's suppose this is your mass, this is your radius that we need to balance, right? For this we have attached some balancing mass at a radius of rotation RB, right? Like this. So in this case, a very important point is that both the masses are in a single plane. Both the masses are in a single plane. So if the masses are in a single plane, moment will not come. Okay, moment will not come, because whatever the force is there, na, it will be concurrent force. So definitely there will be no moment. So directly you need to do what? Static balancing. Okay, directly you need to draw, you need to solve this particular problem with the help of static balancing. How? Just use the net forces equals to what? 0. So what will be the net forces? See, mr omega square. Okay, mr omega square equals to mb rb omega square. So mr, product of mr equals to mb rb. So by this way you can able to calculate what? The mass of a balancing mass. Balancing mass you can calculate, rb you can calculate. Okay, whatever the unknown is there you can easily calculate. Just you need to balance the forces, because both the masses are in single plane, no moment will be there. Now consider another case. This is a case of static balancing. Consider another case. Okay, consider another case. Let's suppose one mass is like this. Okay, let's suppose this is the mass that we need to balance, and let's suppose this is R. For this we have kept M1 one balancing mass, R1 M2 R2, right? Like this. Clear? Now carefully observe. First we'll apply what? Summation of moment equals to 0. Summation of forces equals to 0, right? We'll apply this. So if you apply this, you will get what? mr omega square equals to 0, m1 r1 omega square, m2 r2 omega square. Okay, so product of mr equals to m1 r1 plus m2 r2, like this. So mr equals to mr1 plus m2 r2, like this. Now you need to take the moment also. You need to consider the moment also. So let's suppose I am defining like this: A, B and C, right? Let's suppose this distance is what? L1. This particular distance is what? L2. Let's suppose like this. So for this case I am taking moment about B0, right? Just you need to apply the basic mechanics concepts, right? So if you take the moment, it will be what? M1 R1 omega square into L1 equals to M2 R2 omega square into L2. So it will be like this: M1 R1 L1 M2 R2 into L2. Yes, clear? Tell me fast. Up to this point everything is clear? So you know the concept of static balancing and dynamic balancing. Actually dynamic balancing case will be there when the masses will be in different planes. So here the masses are in different planes, so we can use like this. So it is just a basic mechanics concept only. Okay, a basic mechanics concept is there. Tell me fast, this is clear? This is clear, yes or no? Yes or no, guys? Tell me fast, this is clear? This part is clear? Clear na? Everyone, this is clear. Great. Now moving to the several masses. This is only one mass case na. We'll take a several mass case. Okay, several revolving masses. See, please carefully understand. Okay, now see. See, M1, M2, like this M3, lot of revolving masses are there and corresponding angle of rotation will be like this, theta 1, theta 2, theta 3. Please consider that all these angles are measured from this x-axis. Right, like this. All angles are measured from this horizontal x-axis. Right. So as the masses are what? Concentrated at point, so these are making what? Concurrent force system na. So there will not be any moment, just we need to consider the net forces equals to what? 0. We have to take like this. Clear? Now please consider this particular point very carefully. What are the forces? See, M1 R1 omega square cos theta 1, because we are taking the horizontal components na, so that's why we are taking cos theta 1, plus similarly M2 R2 omega square cos theta 2, plus M3 R3 omega square cos theta 3, plus lastly we need to add MB RB omega square cos theta equals to 0. Theta b, we'll write it like this. Okay. So if you put it like this, MB RB omega square, so omega square will be cancel out na, because every term has omega square. So we'll put it like this, cos theta b, it will be equals to minus summation of MR cos theta. MR cos theta, omega square term is cancelled out, right? From here you can calculate this particular thing. Okay, right? This is clear, each and everyone. This is clear, yes or no? Guys, tell me fast. This is clear, everyone. This is clear na? So you have calculated like this, right? So we have taken the horizontal component only na. Next we have to take the vertical component also. Next we have to take the vertical components also. Clear? Okay, great. See, this is for the horizontal, right? This is for horizontal. Now we'll take the vertical also, and for vertical as well. For the vertical as well, the similar equation will get, right? We'll get a similar equation. So it will be like this. Like this, correct? Each and everyone, clear guys? So these are the equations. Let's suppose if we take the ratio of both these things, what we'll get? So MB will be cancelled out, the tan theta b you will get. And please don't cancel out the negative sign. Don't cancel out the negative sign, please. Okay. Don't cancel out the negative sign. Actually, from this particular thing, it will be very easy for you to understand where actually the balancing mass will be there, whether it is in first quadrant, second quadrant, third quadrant or fourth quadrant. So from this particular point of view, it is very easy. So from the value of theta b, it will be very easy to understand whether it is in first, second, third or fourth quadrant. So we'll define accordingly. The mass, balancing mass will be placed in second, fourth according to the value of theta b that we are getting from this relation. Clear? Each and everyone, this is clear. So I hope this particular point is clear to everybody. So we have discussed the balancing of the revolving masses completely, right? Balancing of revolving masses completely we have discussed. The last case is what? Balancing of reciprocating masses. Balancing of reciprocating masses. Okay. See, first of all, understand the scenario, how the balancing of reciprocating mass is there. What is the scenario in reciprocating masses? Right, this is the case, single slider crank mechanism. Right, this is clear, you know already. This is crank, connecting rod, slider, cylinder. Right, this is all clear. Now please observe, as we have discussed, the unbalanced force is what? Mass into acceleration. Acceleration of slider, mr omega square cos theta plus cos 2 theta by n. Now please see, if we multiply like this, if mr omega square cos theta, mr omega square cos 2 theta divided by n. Now please understand here, the first term is known as the primary unbalanced force. And this term is known as secondary unbalanced force. Okay, primary unbalanced force, the secondary unbalanced force. Why the primary and secondary? Because actually this n value will be divided, na? It is in the denominator and n value will be very large. So because of which this value will be reduces. This value will become what? Reduced value it will become. Okay, so primary unbalanced force, secondary unbalanced force will be there. In some cases they will be asking like this. Okay, they will be directly asking the what is the primary unbalanced force. Okay, so just use this term mr omega square cos theta. Okay, and if they are asking the secondary unbalanced force as well, okay, just divide the primary unbalanced force with the value of n. Right, this is clear. This is clear. So this is the way by which we can calculate these things. Right, guys, tell me fast. This is clear. This is clear. Okay, great. And okay, one more thing they can ask, the maximum primary unbalanced force. See, for maximum value, the cos theta has to be 1. Cos theta has to be 1. So it will be what? We'll write it like this. We'll write like this. Unbalanced primary. So obviously it is unbalanced force, no need to write unbalanced here, but we'll write it here like this, maximum. It will be what? mr omega square. Similarly, we can define maximum secondary unbalanced force, right? So if you want to write it, the secondary unbalanced force, it will be like this, mr omega square divided by n, because in this case also cos theta has to be 1 for the maximum case, right? If we talk about secondary unbalanced force, the cos theta has to be 1 for the maximum case. So if cos theta is 1, the remaining value will become the secondary unbalanced force, that is what? mr omega square divided by n, right? Clear each and everyone? So please note it down fast, guys. So this is the reciprocating mass case that you need to understand, right? Please note it down fast. Okay, please note it down fast. Now we'll see why actually we cannot do complete balancing in reciprocating masses. There is a term known as partial balancing of reciprocating masses that we'll discuss. Okay, done? Okay, we'll see. We'll write it like this, the partial balancing of partial balancing of reciprocating masses. See how we can understand this thing. See, this is your piston, this is your cylinder basically, in which slider is sliding, right? Okay, now please carefully observe. See, as the crank is having a complete rotation, the crank is having a complete rotation, right? Like this. Okay, like this you are having. Clear? Each and everyone, this is clear, na? Now see, please carefully observe. So crank is having a complete rotation, so for that I have drawn this particular circle. Okay, see, what is the unbalanced force? The unbalanced force is like this. Okay, this is our unbalanced force. Let's suppose this is the unbalanced force, but I am balancing on only the primary unbalanced force. Okay, forget about the secondary unbalanced force. First I am doing what? The primary unbalancing. So primary balancing we will do, because this is the primary unbalanced force, this is secondary unbalanced force, this is a very less value as compared to this. So we'll first try to balance this particular value. Okay, so this is a very less value, because n in the denominator part it is having a large value. So when you divide the upper term, the numerator term, with this n which is having a large value, so you will get a very less value. So definitely, so we'll not consider this one for the analysis, we'll consider this one only, the primary unbalanced force. We'll consider the primary unbalanced force. Why? What is the reason? Because it is having a less value, that's why. So what is the value here? mr omega square cos theta, right? So it seems like that some mr omega is there, obviously a centrifugal force will be there. If let's suppose if there is some mass is there, I am assuming some imaginary mass is there having mass m, r is the radius of a crank, and omega square is the rotation speed. This is the theta. So obviously its component will have this value, cos theta term will be there. Okay, So but actually remember this thing, this is imaginary mass. Actually I have assumed like this. Okay, I have assumed this component mr omega cos theta. I have assumed this component, then I assume this. So I have assumed mr omega square cos component will be like this. That's why I have assumed this imaginary mass. So there is no point of assuming this imaginary mass, but just for a convenience purpose, because it looks like a horizontal component of something, na? So for that I have assumed this imaginary mass. So because it looks like a horizontal component of mr omega square, so if I assume imaginary mr omega square, so that's why I am doing some imagination work. Okay, just for having this as an horizontal component of mr omega square, just having as an horizontal component of mr omega square, I am assuming this mr omega in my imagination. I am assuming this thing. Okay, I am assuming this particular thing. Now, correct. But as you know, this is your imagination. Let's suppose this is imagination. But for this imagination, I have assumed a balancing mass. I have assumed a balancing mass. Okay. So consider this thing as a balancing mass. MB RB. But this is the reality, right? This is the reality. Actual, in actual, this is there. To balance this particular imaginary mass. So for that, this will be there will be some components. Okay. For this, there will be some components. One component will be like this. So this is what theta only. This is MB RB omega square cos theta. So from here, our one objective will be fulfilled. What? This will cancel out. This will cancel out this term. Obviously, this will cancel out this term, right? But in reality, this mass is there, na? So obviously, the horizontal vertical component will also be there. A vertical component will also be there. But to balance this one, nothing is present in the system. It is because it is imaginary, na? So how the vertical component will be there? No vertical component, right? No vertical component. So just mr omega square cos theta is balanced by this one, right? This is balanced. But what about this one? This will remain forever, and it will create an unbalanced force which is perpendicular to the line of stroke, and it is known as what? Nothing but the hammer blow. Its maximum value will be known as what? Hammer blow. Remember this particular thing. Hammer blow is the maximum value of the force perpendicular to the line of stroke. The net force perpendicular to the line of stroke will be known as what? The hammer blow. Clear? Each and every one, it is clear. So that's why we cannot do the complete balancing. That's why we cannot do the complete balancing. So it will be there. So we'll write it like this. Causes hammer blow. Causes hammer blow. Clear? Done. Please note it down. Please note it down fast. Note it down, guys, fast. Clear na? Now, see, we cannot do the complete balancing, na? So we cannot do the complete balancing. So we'll do what? The partial balancing part. How the partial balancing will be there? See. This MBRB will be equals to C time MR. Okay. See, if MBRB equals to MR, na, then only it will cancel out, na? Then only it will cancel out, right? But we are not putting MBRB equals to MR. We'll take some fraction of MR only. So we'll say C is what? Fraction of reciprocating mass fraction of reciprocating mass to be balanced. So in this scenario, there will be some horizontal force, F net force along line of stroke, along LOS, line of stroke, right? What is that value? What is that value? C, mr omega square C m, we'll write it like this, mb rb omega square, right? Cos theta is there, na, first of all. Right? So if you take the common part, okay, so it will be like this, mr omega square cos theta. In place of mbrb, we'll write like this, cmr, we'll write it like this, omega square cos theta. Like this, we can calculate the net force along the line of stroke. Next, we'll do what? The perpendicular force to the line of stroke. Perpendicular force, we'll do the calculation for the perpendicular force on the line of stroke. Perpendicular to line of stroke. Okay, net force, basically we want to calculate the net force. It will be what? See, only this one will be there, na? This one, MBRB. You can write it like this, CMR, like this. Clear? Each and everyone, this is clear. So we have discussed completely the balancing of reciprocating mass as well as the balancing of revolving masses, right? So all of the cases we have discussed till now, all of the cases we have discussed. Now moving to the next part, that is what? The CAM. Next part is CAM. In CAM, see, in CAM analysis, the 4 cases are there. For each case, you need to remember the velocity and acceleration relation, right? For each cases, you need to remember the velocity and acceleration relation, and if you know those relations, you can directly solve the questions, right? Because the relation based questions are there. Relation based questions are there in engineering services also and GATE also, right? So just remember all those relation from the different 4 cases, right? CAM and follower, basically the complete chapter name is what? CAM and follower. Actually, because of the rotation of CAM, displacement of a follower will be there. Because of the CAM rotation, displacement in the follower will be there. Now, see, whatever the displacement is there, na, please carefully observe. Y is a function of theta. See, actually, where Y is displacement of follower, displacement of follower, displacement of follower, okay, theta is CAM rotation. Theta is what? CAM rotation. And obviously based on CAM rotation only, na, the follower is displacing. The displacement of follower is because of CAM rotation, right? This is clear. So now consider this point. If you want to calculate the velocity, just take the differentiation dy by dt. If you take the dy by dt, it will be what? D theta by dt, right? D theta by dt will be there. See, I have taken, see, function of theta will be there, na? Function of theta is there. So it depends on the function of theta, how the theta is varying with respect to time. It totally depends on the function of theta. Then only we can calculate the velocity v. It is clear? Guys, tell me fast. This is clear to everybody? This is clear? This is clear? Okay, great. Now, see, one way of differentiation is that, you take like this, dy by d theta into d theta by dt, because as y is a function of theta na, so you can multiply and divide by the theta. Okay, so it will be what, d theta by dt becomes the omega, and it will become dy by d theta. So actually omega is nothing but the rotation of cam. Cam is having a uniform rotation, right? Cam is having a uniform rotation, so that's why omega is for the cam rotation. Dy by d theta, that you need to calculate how the function, how the displacement varies with respect to the cam rotation, that we need to understand in different cases. Okay, so if the velocity is there, you can also calculate the acceleration, dv by dt, like this you can also calculate. Clear? By this also you can calculate. So by this way you can easily calculate acceleration also, velocity also. Just you need to consider the function of y with respect to theta. See, y is the displacement of follower and it totally depends on the cam rotation only. So we are having what, 4 different cases: constant acceleration, or you can say uniform acceleration, uniform velocity, simple harmonic motion, and lastly the cycloidal motion. For each case you need to remember the maximum velocity and acceleration formula, maximum acceleration formula. Just you need to remember all those things only. Clear? Each and everyone, it is clear to everybody? Clear? Yes or no? Yes or no? Clear na? Okay, great guys. So we'll write the formula for, just we'll write the formulas. We'll write the formulas only. First case, uniform velocity case. Actually, see, I will just draw the diagram here first of all. See, displacement of follower, this is theta. Theta basically cam rotation, right? Now please see. So uniform velocity is there, na? So it will be like this: ascent, then dual, then return. Okay. The h is the height of ascent. Okay. We'll write like this. Or we can directly say return also, no problem. Like this. Okay. So up to this point, theta A is there. Theta A for the ascent. Okay. Theta A will be the angle of ascent. So like this, uniform velocity diagram will be there. Uniform velocity diagram will be there. Okay. Now you need to understand the formulas. Okay. Now you need to understand the formulas for the velocity. See, as the velocity is constant in this case, so there will not say like this, it is a maximum velocity or minimum velocity, because in this case velocity is constant. Velocity is constant. We'll say a velocity is constant in this particular case. Can anyone tell me what is the value of the maximum velocity in this case? Can anyone tell me? Can anyone tell me the value of maximum velocity in this case? Anyone? See, please, you need to remember these cases. Actually, in the regular classroom program, we'll do the analysis of all the 4 cases, but at this moment you need to remember the formula only. So it will be like this: h omega divided by theta A, right? This is the formula for the velocity in this particular case. Okay, h omega divided by theta A. Please remember this particular formula, guys. Please remember. In the last scenario, in the last time, you need to remember the formulas. Don't go on the analysis part, because actually this analysis will require some time and definitely will not having that much time in this particular scenario. So all those things will be discussed in the classroom detail. In detail we'll discuss all these things. Okay, we'll do the complete analysis of all the 4 cases in the classes, but actually in the last time we'll do just a formula revision session, na? So just we'll write down the important formulas. What are the important formulas? We'll write it accordingly. Okay. So next case, please write uniform acceleration. Next case, please write uniform acceleration. uniform acceleration. Please write it down. Uniform acceleration. See, here the maximum acceleration formula is what? 4h omega by theta a. Like this, you will having a maximum acceleration. And there is also a maximum velocity formula. Maximum velocity formula, which is double of this one. But in this case, it is like this. 2h omega theta a. So just remember this relation, guys. Just remember this particular relations. Only these formulas are needed. Right? Please note it down fast, guys. Note it down fast. Please note it down. Okay, clear. Now, next case is SHM. Just write down the formulas, right? Okay, just note it down the formulas. In case of SHM, simple harmonic motion. Anyone knows the direct formula for the SHM case, guys? Tell me. What will be the formula for the SHM case? Anyone? Yes, anyone? What will be the formula for SHM case? See, in this particular case, actually this particular case you have discussed in your school level also. From school level we are discussing this case. Okay. But here we are discussing the cam follower case. In the cam follower case, the various steps, see, these four cases are the standard cases. First of all, remember this thing. These all four cases are the standard cases. There may be some more varieties also there, but actually as far as the gauge is concerned, we need to stick to these four cases only. But according to the usage, according to the application, you will see a different varieties of motions are there, because cam has a huge application in industry, huge application, not only in the IC engine but also in the various machines. This cam rotation, cam follower is utilized, right? Okay, some specific machines are there, na? See, what is the purpose of cam and follower? We required a desired pattern of motion. That is obtained from this cam and follower. So this is the main application of the cam and follower. Okay, clear everyone? So apart from maximum velocity, you can also write maximum acceleration, h by 2 pi omega divided by theta a whole square. Like this you can write. Okay, and finally for the fourth case, that is cycloidal. That is for cycloidal motion. Guys, note it down fast. Note it down. Okay, so velocity is same here also. The velocity you will find same. Okay, 2h omega theta. See, 2h omega theta, the uniform acceleration case, the same velocity you are getting here only. Okay, and maximum acceleration, please write it down, the value of maximum acceleration also, 2 pi h omega by theta a square. This is important, right? So all these four cases, right? All these four cases, first, second and third. So this is the basic mechanics part. Okay, this is the basic mechanics part that you need to know. And these four cases, maximum velocity, maximum acceleration, maximum velocity and maximum acceleration, that you need to know. Okay, uniform velocity, basically a velocity constant, constant acceleration, simple harmonic motion and a cycloidal motions. Okay, right? Now, so we have come to the end of this particular part. Now, last and not the least, actually it is what? The vibration. See, the basic part of vibration we have discussed in the engineering mechanics, right? We have discussed the basic part of vibration in engineering mechanics, so I will be quickly covering all those topics because it has been covered in the engineering mechanics class, right? So first of all, if we consider undamped, single degree of freedom, undamped vibration. Okay, see, if you have this case like this, or you are having like this, or like this. So in all these cases, you will see under root k by m. In all these cases, you will see the formula for the natural frequency will be under root k by m. Clear? See, all these cases we have discussed in engineering mechanics. Please watch that engineering mechanics part. The formula seed revision session for the engineering mechanics that we have discussed on 24 December or 24 January, sorry. On 24 January, we have discussed that engineering mechanics part. So those guys who didn't watch that particular session, please go and watch the engineering mechanics part also. Okay. In engineering mechanics part, we have discussed the basics of vibration. We have discussed the undamped part because it is common to civil also. That's why we have discussed. Okay. But just for a recapitulation, I am writing all those things, right? So please, those of you who have not attended that particular engineering mechanics revision session, please go and watch on 24. It is available on basically in our YouTube channel only, but the date will be on 24 Jan. It has been uploaded, right? On 24 Jan we have taken the engineering mechanics session. So both the mechanical and civil combined part is there. Okay. So we have also discussed the application of friction part, that is belt and screw. Okay, that part is also covered, right? So this is undamped vibrations case, right? So if there is a combination of springs is there, like suppose series and parallel, all those things are already known to you. Okay, that we will not discuss because it is very basic. But just for just taken as a factor of safety, please understand the methods to solve. Methods to calculate omega n. Methods for omega n. What are the methods? First is energy method. Calculate the total energy or differentiate the total energy with respect to time. Because as far as the mechanical energy is conserved, we can say we can differentiate the total energy, and definitely it will be what? 0. Because if it is a conserved, it is a constant quantity. If we take differentiation, it will be 0, na? So from this you can get the omega n. Second case is what? The torque method, or apply Newton's second law. Or we can say like this, torque method. Most of the people will call it as a torque method. Actually both are same. Okay, most of the people say a torque method, but it is same as compared to the Newton's second law. Both are same. Nothing difference, nothing any difference in Newton's second law and what? The torque method. Both are same, exactly similar. Exactly similar. All these cases are exactly similar. Guys. Okay, okay. Each and everyone up to this point, everything is clear. Everything is clear. So now the damped part is important, right? The damped part is important. We'll write it down some important points for the damped vibrations. Okay, correct. So for the damped vibration, as you all know, we are providing the damping. Damping is having a dissipative effect. It reduces the energy, and that's why our vibration will get reduced because of the dissipating effects. Right. Now, please consider this particular case. this is the mass, right? Like this. So whatever the case, like this, in this case we will write the equation as what? Mx double dot plus kx equals to 0 na, like this we are writing. But in this case we'll write the equation mx double dot plus cx dot plus kx equals to 0. C is what? The damping coefficient. Tell me, up to this point clear, everyone? This is clear to everybody? This is clear? Great, great. So this is for a linear part. Let's suppose if I talk about the rotation case, this is for linear, na? If we talk about the linear case, it will be like this. It will be like this, c theta dot plus kt theta. For the rotation case, right? Like this. So this is for the linear one, another is for the rotation one. Clear? Tell me, up to this point everything is clear? Each and everyone, guys, each and everyone, this is clear, na? Yes, yes, it is clear. Okay, great, 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 guys. Okay. So as far as the damped systems are considered, we have three different cases. First, the under damped, critically damped and over damped. Three cases are there. We have three cases, right? So we'll write it accordingly. We'll write it accordingly. Okay. Types of system, see. First is basically undamped, in which no damping is there. Another is what? The damped. Now, please carefully observe. For this term is 0. Can anyone tell me what is this term? Under damped, critically damped, over damped. Can anyone tell me what is the meaning of this term? Less than 1, equals to 1, greater than 1. Yes, tell me fast. What do you mean by this term? Anyone? Nobody knows about this term. Damping ratio, guys, damping ratio. Okay, it is what? The damping ratio. Damping ratio. Okay, clear? So please note it down fast. This psi term is known as damping ratio, and based on this value we will define system as undamped, critically damped and over damped. Okay, note it down fast. Done? See, this damping factor is nothing but the C by Cc, the damping coefficient divided by critically damping coefficient, right? So its formula is, again we can write it like this. Please remember all these formulas, right? Okay, please remember this formula, right? So all these formulas are very important. See, any of the parameters are given, so accordingly whatever the parameters are given in the question, you will use the formula, right? You will use this particular formula. And also remember, the critically damped coefficient is nothing but the 2m omega n. right? Clear? Everyone, each and everyone, this is clear. Up to this point, everything is clear, na? Yes or no? Yes or no, guys? This is clear, na? Okay, okay, great, great. So we have defined the critically damped, undamped, and overdamped. We have defined the critically damped, undamped, overdamped systems, like that we have defined. Okay. So see, we'll discuss the underdamped. Okay, we'll discuss the underdamped case. So apart from this, you should also know the damped frequency. Most of the time they have asked this question. What is the damped frequency? What is the damped frequency? See, for damped frequency, the formula is this is the formula that you need to remember for the damped frequency. Okay. Yes, Pranjali Sharma, damping ratio, correct. Yes, correct one. See, you need to remember all three formats of this damping ratio. All three formats you need to remember. Okay. Whatever the given parameter is there, accordingly we'll select the formula for the psi, for the damping ratio, or even we can also say it as a damping factor, right? We can also say it as a damping factor. But remember this particular formula, damped frequency, it is very important, right? So note it down fast, note it down. Okay, clear? See, the equation that we have written, previously the equation we have written like this, we can modify again, we can modify this equation again. How? See, mx double dot plus cx dot plus kx equals to 0, like this we are having, na? So x double dot c by m x dot plus k by m x equals to 0, like. So what is c by m from this particular factor, from this particular formula? C by m we can write it like this, carefully observe that. C by m we can write it like this, 2 multiplied by damping ratio multiplied by omega n into x dot plus, in place of k by m we can write it omega n square into x, like this. This formula, this relation you should also know. Okay, this relation you should also know. Okay, because sometimes they will give the equation directly, so from that equation you should know this term is representing what? Omega n square, this term is representing 2 psi into omega n, like this you should know. Okay, clear na everyone? Clear everyone? Okay, so one important point in the case of underdamped system is that the ratio of successive oscillations, the amplitude of oscillations is same, or we can say is constant, right? The ratio of successive oscillation is what? Constant. So for that we have defined a term as a logarithmic decrement. Can you tell me what is logarithmic decrement? Okay, actually it is related to that only, that's why I have discussed that particular point. The successive collision, the ratio of successive collision is what? It is what? It is constant, na? So accordingly we have defined a term next, we have defined a term known as logarithmic decrement. Logarithmic decrement. Okay, can you tell me what is that formula? What is the formula for this logarithmic decrement? See, it is very important for the GATE examination as well. Okay, because most of the time they have asked the questions from this logarithmic decrement. Please remember this particular formula. Okay, directly they will either give you the damping ratio and directly they will ask what is the logarithmic decrement. They will give you the value of psi and they will give the value of damping ratio. Okay, or they can even don't directly give the value of damping ratio, they will give some parameters based on which you can calculate the damping ratio, and after that you need to calculate the logarithmic decrement. So such type of questions can be framed. Such type of questions can be framed, right? So you need to aware of that. You need to aware of all the relations that we are having, right? You need to aware of all the relations that we are having. Okay. So in the similar way, another format will be what? ln xn divided by xn plus 1, like this. It is the ratio of for the n cycle, and it is the ratio for the basically it is the amplitude for the n cycle, and it is in the denominator, it is the amplitude for the n plus 1 cycle, right? Like this we can also define. Clear? Each and everyone, it is clear na? Yes or no? Great, great. Okay, so by this way we can define all those things that is required, okay, to calculate the logarithmic decrement. All those things we can calculate by this. Okay, all those things we can calculate. Okay, so in this case, see, in this case of damped system, we have not applied force. It is what? Undamped. Obviously it is a damped vibration, right? But there is no force vibration. But if we apply some force, it will become what? Forced vibrations. Forced vibration it will become, and obviously it is the damped system, na? So we can apply the force, na? So okay, the logarithmic decrement is covered. This formula, and again this last one formula for this one. Okay, for the n cycles, sometimes they will give the amplitude for the first case, for the not, and this is for the last, and total number of cycles they will mention like this. So accordingly you can use this particular formula. Accordingly you can use this particular formula, right? Now the case for the forced vibration. Carefully observe. Let's suppose some force is there. F equals to F naught sin omega t, like this. A force is applied on the body. Okay, now the equation will become like this: mx double dot plus c into x dot plus kx, it will equals to F naught sin omega t. Now in such cases we need to calculate the amplitude for the vibration. In such cases we need to calculate the amplitude of vibrations as well, right? Magnification factor, all those important parameters are there from which GATE has already asked a lot of questions. GATE already has asked a lot of questions from this particular things, like amplitude of vibrations, steady state vibrations, right? What is the magnification factor? What is those things? All those things they have actually directly asked in the GATE examinations, right? So we need to know, we need to understand what are those formulas that we can use to calculate all those values, right? First of all, tell me, it is clear, na? It is clear. So first of all, tell me what is the steady state vibration formula? What is the steady state vibration formula? What is the steady state vibration formula, right? So say we'll write it only important formulas, right? We'll write down only important formulas. Steady state vibration. See, A equals to what? F naught by K. See, F naught is what? This F naught sin omega t. K is the stiffness of the spring, under root 1 minus R square, a whole square, plus where R is nothing but the omega by omega n. It is a frequency ratio, right? It is nothing but the frequency ratio, omega by omega n. Clear? The steady state vibration, this formula is very important, guys, very important. Okay, very important. R is what? The frequency ratio. R is what? The frequency ratio, omega by omega n. Clear? this is clear. Omega by omega n is the frequency ratio. By this formula, you can directly calculate the steady state vibration. Yes? Okay. Got it? Yes or no? Tell me first. Yes or no? It is clear, na? It is clear, na? Everyone? Okay. So sometimes, see, steady state vibration is clear. Sometimes they will be asking the magnification factor. Sometimes they will be asking the magnification factor. Right? They will be asking the what is the magnification factor. So you need to calculate that magnification factor also. You need to calculate the magnification factor also. So it is the ratio. Magnification factor is nothing but the ratio. So we'll write it down, the magnification factor as well. See, it is equals to amplitude divided by f naught k, right? Amplitude divided by f naught k, right? Amplitude what? Steady state vibration amplitude. Amplitude of steady state vibration. It is what? Amplitude, right? Write it complete. Amplitude. Amplitude of steady state vibration. F naught by k will be what? The deflections will be there. So A divided by f naught k is nothing but the amplitude magnification factor. So this formula will become like this: 1 minus r square whole square plus 2 psi, that is damping ratio, its whole square, and it is in under root. Right? This is clear? Yes. Tell me. This is clear, na? So lot of questions they will be asking from the amplitude of a steady state vibration, and lot of questions they are asking from the magnification factor. Now let's suppose they are asking, see, one question is that they will be asking the maximum value of magnification factor. At what value of r it is having a maximum value of magnification factor? Can anyone tell me what is the maximum value of magnification factor? What is the maximum value of magnification factor? Can anyone tell me? Can anyone tell me what is the value of maximum magnification factor? Value of magnification factor which is maximum. See, first of all, see the expression of magnification factor. It is a function of r comma damping ratio. Frequency ratio and damping ratio are the two parameters on which the magnification factor is depending. So see, magnification factor is maximum at r equals to under root 1 minus 2 psi square. So please remember this one again, very important. Right? This particular formula is very important. Directly they will be asking, a magnification factor is there, tell me the value of frequency ratio under which the magnification factor is maximum. They will be asking the value of frequency ratio. They will be asking value of frequency ratio under which the magnification is going to be maximum. So directly by using this particular relation, you will get the answer. Actually, all these relations come out after the analysis of underdamped system. So obviously we are not doing the analysis, we will just writing the formulas, we are writing the relations, so that it will be clear to you that which formulas are important for the examination. Which formulas are important for you, the examination. Okay. So those formulas we are writing like this. Each and every one, it is clear, na? Any questions, any doubt? Any question, any doubts, guys? Up to this point, any doubts? Okay, no, clear. So after this magnification factor, vibration isolation topic is there, in which they will be asking the transmissibility or transmissibility ratio. They will be asking like this. Okay, from that topic also GATE has asked. So we need to understand what is the formula for the transmissibility. We need to understand the formula for the transmissibility, right? So please write it down. See, generally by this term we are representing, or you can also use TR. Okay, it is equals to under root okay, like this. This is the case, this is the formula for the transmissibility. Guys, everyone, this is clear na? Everyone. So what is the purpose of calculating this transmissibility? Actually, it is the measure of performance of the vibration isolation system. So it measures the performance of the vibration isolation system. How much amount of vibration has been transferred or transmitted further, right? So we have to calculate this transmissibility ratio so that we can understand what is the performance of our vibration isolation system. So I hope this is clear to everybody. I hope this is clear to everybody, guys. Tell me fast. Yes, clear na? Clear na, everyone? So all those formulas are important, guys. Just remember this particular formulas, and see, still vibration is also a very lengthy topic. So it is not possible to cover all the analysis part. Just we have discussed only important formulas and important relations from which questions will be there in the GATE examination for sure. So thank you so much for attending this particular session, and I hope all of you will get a very good mark in GATE examination, and I wish you all the best for your GATE examination and your future career also. Thank you so much, guys, and if you like the session, please like this particular video and share this video to your friends also, okay? And if you like this session, please, you can also comment in the comment box, right? Thank you so much, guys. Thank you so much.